My name is Simon Ems, and so just a bit of admin. Initially, this talk was entitled The Beekeeper's Guide to Mentoring Engineers. For various reasons, I'm doing a different talk today, which is, as you can see, tech is broken and I won't fix it. So if anybody thinks that sounds boring, I won't take any offence. If you want to leave, that's fine now, but do it now. Okay, so yeah, welcome. My name is Simon, and I'm here to talk about why I think tech is broken and AI won't fix it. So the focus of this talk is primarily going to be on the first section, the tech is broken, and what we as engineers and senior engineers can do to hopefully improve that. And I also think in a lot of these places where I think it is broken, AI won't make it any better, and it, in many cases might actually make it worse if we just continue blindly down the path that we're going. Okay, so the original inspiration for this talk was a really poor recruitment experience I had about 12 months ago now. And I had this really bad experience at recruiting, and basically what happened was a guy phoned me up, he said, hello, we're looking for somebody to come and help our platform team. And I said, yep, that's brilliant, that's exactly what I do. And he said, we want you to come in and we want you to be opinionated. We want you to be an opinionated leader to help us fix some of our previous mistakes. And I went, yep, that's good, I can do that. I've done that many times in the past. And he said, there won't be any technical tests and it's going to be a two-stage interview process. I went, that's brilliant, that sounds good. And then we got to the end of that, no problem. He said, right, I'd like to get you back in for another one. Yeah, no worries. And then about 2 days later, I had an email come to him and it said, right, okay, so the first stage is a technical test and then the next 3 stages are going to be this. And I said, well, hang on a minute, I thought you said there's going to be no technical test and it's only going to be a further stage. And he went, oh, no, I've changed my mind on that. And I went, well, okay, this is my opinion. I don't agree with that for these reasons. And he said, we don't want you to be, I don't care about your opinion. To which I said, I thought you wanted to be opinionated. He said, oh yeah, when you start here, not at this point. Okay. And I went down the pub with a mate of mine and was whinging about this, and he said, stop your whinging, this is actually a good idea for a talk, get talking on it. So here we are. One of the big problems I think we have in tech as a whole is we don't actually know how to recruit engineers. The first one is how many rounds of an interview we do. Some people say 1 interview, other people go, oh, we've got to have 11 interview stages and we've got to really make it look, and the people just fall out because they get bored. Well, what are you doing at each of those stages to make those interview stages worthwhile? If you're just having 11 conversations with people, what's the purpose of them? If you're only having 1, how do you make sure that you've got the right things and that they know the right things about you as a company and a team? We also have technical tests. Now, personally, I'm not a fan of technical tests. Do you know the reason why I don't like technical tests? Because I'm shit at them. I've been doing tech for a long time. I've been doing this nearly 20 years. I'm really good at my job. My job is not doing technical tests. I know some people I've worked with in the past, and they're absolutely brilliant at technical tests. They're not what I would call people whose opinion is tech I respect. That's the polite way I'm going to say it on camera today. But how does that actually help? So we've got this technical test. We've then got to have the conversation of what type of technical test. Is it going to be leak code? Is it going to be the dreaded whiteboard interview? Is it going to be architecting something when your actual job is junior engineer and you're not going to be listened to when you try and architect something? What is making a junior engineer who really doesn't know an awful lot? What is the point of making them architect something where then that's not actually their job? The other thing that I always think is, now, as engineers, we like a feedback loop. That's what the DevOps cycle is. It's just an ultimate feedback loop. How do we get accurate feedback on interviews? Because the person we're interviewing is trying to impress us. If I say to somebody, right, I'm not going to give you the job, but what did you think of the interview process? Oh, it was shit because you didn't give me a job. Okay, fair enough. Was it actually shit? Or are you just grumpy because I didn't give you a job? If I haven't told you whether I'm going to give you the job or not, are you going to say, oh, yeah, it's brilliant, absolutely loved it? I can't be certain it's an accurate feedback loop and that information I'm getting is accurate. Even if we anonymise a test, can we actually be definitely certain that we're saying this is a truly anonymised test or a survey that we're being given out? Unless I know what it is coming in, unless I'm the person who knows it, can I be honestly truthful about what I'm saying in these there? A lot of people then just go, well, let's just follow the FANG, Facebook, Apple, Amazon, Netflix, Google. Don't like acronyms, so I like to explain what it means. Well, that's great, but I'm a 3-person startup in Birmingham. Can I legitimately say I'm going to make it exactly like a FANG interview because that's what FANG do? When, one, I'm not FANG. A friend of mine went to work for Amazon about 6 or 7 years ago. He's an architect there, does a very good job. And one of the reasons he had, I think it was 7 interview stages. And when he got the job later on, he said, why is there so many in the interview stages? And he said, the person who interviewed him said, well, we just have that many because people then drop out. And it then becomes a method of attrition to see how far you can get. Now, that was an anecdote. I don't know actually how true that is, but I've heard that from a few places. Is that is resilience, and whether you can be bothered to stay into an interview process into the 7th or 8th hour, is that an accurate appreciation of somebody's technical skills? It's also, you're going to get a lot of people who go, this is not worth it for me doing 7, 8, 9 hours worth of free work for some multi-billion-dollar company. I can do better things with my time. I can be better appreciated. My sister, she works for the NHS, and one of her jobs is recruiting surgeons. She works for the NHS in Bath, about 100 miles west of here. And I was talking to her one day, and I said, so how do you actually recruit a surgeon? She said, well, we have a conversation with them. We interview them, we check their qualifications, we verify their qualifications are as what they say they are, we talk about them, we have a conversation. And I said, okay, that's great, that sounds a bit like tech. Do you do any technical tests as well? She said, no, apparently it's wildly unethical to chop somebody's leg off in an interview. Who knew? But that's what we're effectively asking people to do by saying, go and build this application in a test scenario. Okay, so who agrees with this statement, please? Hands up. Let's get you doing some exercise. Oh, we've already got one hand up now. Thank you very much. Right, keep your hands up if my company struggles to recruit well-trained engineers. That's a good number of hands there. Keep your hands up if your company also recruits junior engineers and trains them up. So a lot of hands went down, some hands went up. I'm very pleased to see that some hands stayed up. That's good. A lot of companies that I've worked with view junior engineers as a cost centre, and I think that's wrong. Junior engineers are your future senior engineers. This is even more true with AI. A lot of people have said AI coding is going to kill the junior engineer path. Great. How are we going to get the future senior engineers? You don't just magically get a senior engineer out of nowhere, but a lot of companies do treat it as we only recruit senior engineers. And it's somebody else's job to make those junior and intern engineers into senior engineers. Junior engineers, I'm going to make a case for recruiting junior engineers here. So if you're one of these people and you're in a position of authority in your company, I would advocate recruiting junior engineers. They force senior engineers to explain things better. They force you to collaborate better, to coach better, and to inspire better. One of my jobs as a senior engineer is to mentor people. Which is what actually the original talk should have been today, was mentoring people and some of those experiences that I found. But by mentoring people, not only are you making the junior engineers better, you're making your senior engineers better. Now, there's a direct correlation with that, because the point of senior engineer is you've got to go and explain it to new people. Even if you bring a senior engineer into your company, a new senior engineer who doesn't know what you're doing, the senior engineers have to tell them, this is how we do things, this is what we're doing, and we build things like this, and this is actually how we do things in this company. And can you please also tell us how you would improve that? They're also the ones who are going to be talking to customers. Customers aren't going to know anything about your product until you're the expert in your product. If you're going out there and talking to customers and potential users and other developers and DevX and what have you, you've got to be able to communicate that with people. It also creates psychological safety and empathy, which is something that as engineers we can be lacking. I work for a coding boot. I did some work with a coding boot camp for a couple of years ago in Birmingham, and the junior engineers struggled to get jobs after this coding boot camp because a lot of people would go, we're not going to recruit people from a coding boot camp. But the difference is that I was working with these people for 12 weeks, I think it was. They were really, really good. They needed help, they needed moulding, but they were really, really good people who were good at their job. The teamwork part of it as well. Now, the team is the most important unit of your company, of your engineering cohort. You might have one big team, you might have many small teams. A couple of years ago, I was the leader of a platform team, and there's 4 engineers in there, and my job actually changed from what I was recruited for, because I recognised that the job I was recruited for was not needed within this team. We had 3 brilliant engineers. My job as lead engineer wasn't necessary. What I actually ended up becoming was an engineering manager, because that was the bit that team lacked. But of course we had 4 people. So we had me as the lead engineer. We had the best engineer, shall we say, who was absolutely brilliant, and people would always go to him and say, Antoine, can you help me with this? And a lot of his time was spent explaining things to people. We'd have Billy as well, who was just as capable as Antoine, but was not quite as well known. So he was he was a really, really good engineer, but everyone would go to the other guy. And then we had Connor, who was the nominal junior engineer as well. And one of the things that I had to say to them all, we are all playing roles. Just because you're the junior engineer or you're the lead engineer doesn't make you better or worse than anybody else. We are in a team and we're all fulfilling roles. So sometimes I'm going to be the junior engineer if this is on, BGP network, which was always confused me, which was a lot of things we had to do in there. I'm going to be the junior engineer in there. But if it's something on how to scale lots of Kubernetes clusters, well, that's my wheelhouse. I'm going to be able to lead that. And it's all about playing different roles. I also think Agile is broken. Who uses Agile in their workflow? There's a couple of very lucky people who haven't put their hands up. Now, one of the reasons I say Agile is broken is because we have all these frameworks, whether it's Kanban, Scrum, XP, or whatever you want to call it. That is the entirety of the Agile Manifesto. If you go to agilemanifesto.org, I think it is, that is the first page. Slightly cut off, but it's 4 aspects. Where's the daily stand-up in there? I can't see it. What about your sprint retrospective and all the other ceremonies that we have? Now, I know those are different flavours of Agile, but the different flavours of Agile often detract from this point. Working software. I've worked in places before where they go, oh, we can't finish this sprint until the documentation is done. But we've got working software. Oh, no, we've got to have the documentation before we can declare this finished. Now, if we prioritise working software over comprehensive documentation, for example, I would argue that is done, according to the definition of the Agile Manifesto. As another little side point about Agile, if we don't start a retrospective by going over the actions of the previous sprint, is that a worthwhile retrospective? I don't know. I don't think it is. A number of times where somebody goes in, right, okay, what was good, bad and indifferent this sprint? Well, we've got 17 actions from the previous sprint, probably too many, but neither here, it doesn't matter. Can we go over these to make sure we've done? Because I know a lot of places I've worked, the first time they're looked at is 20 minutes before the next retrospective. My experience of Agile is, or a lot of companies is, they say that we're Agile because they use Jira and have a stand-up. Who listens in stand-up? I certainly don't. I very often drift off because there's always one person who just drones on and on and on and on and on. And I did this yesterday and I did that and then I had another and then this. Who cares? If you do have somebody who's like that in your sprints and you have to have a stand-up because of team politics, run it to the rules of just a minute. No hesitation, repetition or deviation. Speak for 60 seconds. That's how I like to run my stand-ups. Bias is a big topic in tech at the moment, and I think rightly so. We all have biases. We all have unconscious biases. How do we know it's unconscious? I don't know what my unconscious biases are. I can only necessarily say what somebody else's unconscious biases are, and they might be able to say what my unconscious biases are, but I can't tell because they're unconscious. Let's imagine a conversation. So it's a conversation that we might have had with our mothers. Hello, I'm sorry I'm late. I've just come back. I've just been to the doctor. Oh, great. What did he say? Well, she. At no point have I said that the doctor is a man. And my mother has assumed that the doctor is a man because that's her biases. So I can say to my mum, well, actually, my doctor's female. This is who she is. She works at this, that, and the other. And I can have that conversation and say to my mum, doctors are not all men. It's fine. I can have that conversation with a fellow human. Let's do this doctor test with AI. I've just seen a couple of knowing smiles. I assume everyone knows where I'm going with this. I said to deep AI, draw me a picture of a doctor. White man with glasses. White man with glasses. White man with glasses. White man with glasses. White man without glasses. White woman without glasses. Okay, fair enough. How do I say to AI to check your assumptions? AI is not a thing where you can necessarily have a feedback loop. It's also not deterministic. So it might then go, well, I'm going to do it for Simon. I'll do somebody who's not an old white man with glasses, but everybody else will be the old white man with glasses. This is a picture of my doctors in Telford, where I live. No old white man with glasses. Now, as an old white man with glasses, I think that's a disgrace. Thank you for the laughter. Coding. Now, this is another big topic in tech at the moment. I'm old enough. I'm 43. I started 20 odd years ago. My first journey into coding was to go on Stack Overflow and say, how do I do this? I'd then get shouted at by somebody saying, why are you doing it like that? And of course, with Stack Overflow, there's a few people who probably use Stack Overflow, maybe we still do. It can be good, it can be bad. And if you copy and paste it from Stack Overflow, you're effectively copying and pasting blindly. You don't know whether this is good, whether it's bad. Once it's in your code base, committed, etc., it's there and you have to maintain it. Is AI code generation just a way of automating that, making it a lot faster to get shit code into your code base? There's a meme going around this week I noticed where it's, how we used to do it 20 years ago. We'd go onto Stack Overflow and then we'd spend 6 hours writing it and then 3 hours debugging it. Whereas now with AI, we can get it all in there instantly, but we can spend 24, 48 hours debugging it as well. Are we just setting up a time for ourselves for future problems? Humans, one of the things about humans which is unique is the spark of creativity. That moment of inspiration. It might be you've come back from a walk, it might be you've had a shower and you've thought, oh, this solves that problem. That is uniquely human. I don't believe you can replicate that with AI. If Gen AI uses large language models to generate all code, and it looks at those from what was done in the past. It might be an old version of the thing you're using. It might be the absolute latest version. It might be good. It might be bad. If we use 100% AI-generated code, when they're looking at past code to look at, how long before it's just regurgitating other AI code? Will we get to a stage, if we go for extreme, no human code is generated, will we get to a stage where no interesting code, nothing unique is ever created again? It's a thought experiment. It's not, I don't think it's realistic. I think there'll always be some people who go, I'm going to write my code by hand fully, and other people will say, I'm going to write my code by AI fully. But if you go to the extreme, where does that new code come from? Going back to, I mentioned earlier on Just a Minute, Radio 4 show. Another one of my favourite Radio 4 shows is I'm Sorry I Haven't a Clue. There's a game in there where you just name tube stations. It's very funny, honestly. To anybody who's not British and never heard it, trust me, this is proper British humour. But of course, everybody knows you can't go from Gloucester Road to Heathrow Terminal 1, 2 and 3. But I've played Mornington Crescent with AI, and I've gone for hours and hours and hours, and it never goes to Mornington Crescent to finish the game. Because it just follows, I'll do this because that's what other people have done. Is it going to end, are you going to end up with feedback loops where it just goes back and back and back and goes on and on and on? Random blank screen there. I don't know what that was. Ah, there we go. I was pressing the wrong button on here, that's why. What can we do? I think the best thing we can do is be an empathetic human. AI cannot, by definition, be empathetic. It can simulate empathy, But the best way you can be empathetic is going, if I was in this situation and I was talking to this other person, how would I feel? What would make me feel better? And if you're not naturally an empathetic human, that's fine. You can ask them. It is allowed. You can say, I don't know how to make you feel better. I don't know how to work best with you. Can you please tell me what I can do to make your life better, to make your work better? That is a perfectly legitimate question to ask. Develop engineers. We're all developers. We know how to build something from nothing. Take those same principles of building something from nothing and do the same with engineers. There's a rule that I've called it the Peep Show rule. There's a TV show in the UK called Peep Show, very, very funny. The same writers who did it have gone over to make Succession in the US. And one of the rules they had in their writer's room is, you can't say no to a joke. And I run that in my teams as well. You can't say no to an idea. You can say, I can make this idea better if we do this. I think that's a better way. But you can't say, no, that is shit, you can't do that. That is the rule that I run in my teams. That is another thing that we can do. Treat AI as your unreliable colleague. I'm an unreliable engineer. Sometimes I do absolutely brilliant work. Other times I come back and look at it 3 months later going, what idiot wrote that? Look at Git blame. Oh, it was me. I write crap code. Don't assume that AI is right because it's got those letters AI. And the point is that this stuff is not easy. People who are making claims about AI solving all your problems, they're selling you something. Remember the famous line in the film, The Princess Bride? Life is pain, and anybody who tells you otherwise is selling you something. Somebody says that AI is going to solve all your problems, they're probably selling AI. That is my talk. I'm open for questions. I've put a QR code on there as well. If you want to get in touch with me, please do so there. If you want to leave me feedback on my talk, please do so as well. And I'll be taking questions. I think I've probably got another 3 or 4 minutes. Oh, I've got 5 minutes. Time that all right? Yes, please, questions. Anybody? I think there's a microphone coming around as well. There's no microphone coming around. I'll just repeat it for the benefit of the tape. Yeah. Okay, so the question was about have I worked with government, because it does things slightly differently to FANG. I've worked with the UK government, and I've worked with the American defence sector. I've worked with those as a consultant, not in a recruitment capacity, no. Is there anything that you want to share that maybe could help? Yeah. So Jan was saying that the consultant role, basically, it's similar to, if I understand it, was similar to how it works in the military, where you're effectively a number and they can't pay quite as highly. Am I right from your accent? You're German. Yeah. Never worked with the German government, so I don't know. I have done a bit of stuff with the UK government, and that's a similar experience that I'm told by friends of mine who do work in UK government departments as well. One thing I would say, actually, I'm not the greatest fan of the 2010 onwards government, but one of the best things they ever did was they set up the, it's called GDS, the Government Digital Systems. They've done an absolutely brilliant job, and I know some of the stuff that actually work in the central GDS department, they do pay well, and they do have a really good ethos, and they do very, very good work. In terms of actual government departments, they still pay them threepence halfpenny. And they're sort of half the pay of what they would be in the private sector as well. So I guess it's which way you go. It's depending on which section you're in. We have time for one more question. Yeah. Oh, sorry. Yeah, sorry. I thought that was your hand up to say. Yes.
and how the AI perceive generating that image. What do you think it's going to take as we bring in the next wave of engineers to change? Is that going to be how the inputs that we put into these models, or do you think that'll evolve over time, or do you think it's going to stay the same?
Can I have an easy question, please? Yeah, question was, what do I think it's going to take to sort of sort out the inputs and to sort out the biases in AI? This is where I'm vastly underqualified to talk about the question. My gut feeling is that it's a human solution. It's not. It goes back to what I said about treat AI as an unreliable colleague. In the same way as my mum assumed that my doctor was male. That's based on 1,200 years of history. It's not an unreasonable assumption that my doctor would be male. Based on 2024 as it was when I had it, it is an unreasonable assumption. But if you say, I'm going to generate a picture of a doctor, and if you don't notice that it's all old white men in glasses, then the problem is on you. It's not the problem on the AI, is my argument. Very happy to take alternative answers on that if somebody else has got a different viewpoint. One more question if there's time for it. Well, no, there is time for it if anyone's got one. Yes.
What is your ideal interview process?
My ideal what, sorry?
Ideal interview process.
Oh, what's my ideal interview process? I like a good conversation, is personally how I like to do it. I like to say, what are you good at? And I don't mean it in the sense of tell me your biggest weakness, because that's a crap question. But I'm very happy. I want people to come into an interview. When I interview somebody, I want that person to get the job. And that's true of all interviews I go on, because that's a really good use of my time. If I come to my boss and say, right, I've got 4 candidates here, they're all really good, and I think we could offer all 4 of them the job, and they get all 4 of the job, that's really good use of my time because I've been good. Or that's been a good process for me. Give them the real problems that you've actually got. It's no good saying, right, build me a linker table. How many times have you ever done that in your real job? Oh, I've done more about 15 years. Right, great. So it's a completely pointless question then. If you're going to do a technical test, and if that's just how your process is and that's what you think is a good thing, that's fine. I'm not against what you think is a good process. Make it relevant. Whatever questions you're asking, make it relevant to the job that they're applying for. And if you think, right, okay, it is a perfectly legitimate thing to say, our code base is crap, we haven't got a clue, we're in mess. Great. So you're going to want somebody who's different to, this is a perfect code base and it's absolutely perfect and it's running on everything. Different. You're possibly wanting a different engineer. So ask questions regarding that and model it around what you're actually going to be making them do in that process. Right. I think that is my time up. Thank you very much, everybody, and please tell me what you think.
everyone. Welcome to my talk. The room's a lot more full than I expected. You'll see me looking at this screen a bit because for some reason Mirror isn't working. Okay, so I'm talking about geographically distributed clusters by yours truly, Alex Bisesar. So a bit about me. I'm a Kubernetes and cloud enthusiast. I'm one of the organizers of Cloud Native Mauritius. I work at this cool company called La Sentinelle back home. I'm like the Kubernetes person there. I like a lot of things, Linux, free and open source software, and so on. And that's me with my home lab. It's in the living room, and it's fun having a Kubernetes cluster in the living room. If you don't have one, I encourage that you do have one. So that's how I started with Kubernetes, and then I ended up here. So, all right. The cloud in Mauritius. So, does anyone here not know where Mauritius is? Oh, wow, a lot of you have gone on holiday there, it must seem. So, Mauritius is a small tropical island in the Indian Ocean. If you want to put it, it's like east of Madagascar. Well, at least the government likes to say that we are the fintech hub of Africa, which is a lot of big words which don't really apply. I'm here, well, we're talking about Cloud Native. So what is the status of Cloud Native in Mauritius? Not good. It's more like Cloud Naive, as I like to say. So until very recently, the government's official stance was that, hey, the cloud is really bad, don't use the cloud, everything stays in Mauritius. And then they started putting our data on the cloud and all of a sudden it was fine. But other than that, many companies, they view the cloud basically just as someone else's computer or a VM on AWS. They don't see cloud for the possibilities of cloud native or the whole landscape which comes with it. So fortunately, I work at a company which sees Kubernetes like as something valuable, but that's not the general case in Mauritius. And as a consequence, I think we've lacked a lot of the development which could have brought us to a more cloud native technological landscape back home. So I think one of the interesting things to show is the networking situation back in Mauritius. We're here. Little tiny dot. So zoom in a bit. There. We've got maybe 2 or 3 internet cables under the sea which connect us to the rest of the world. And for a country which says that it's like the fintech hub, the technology hub of Africa, having only those few connections is a real problem. Because sometimes you get internet outages when something happens to one of those cables, and now all of a sudden ping to Europe is like 600 milliseconds. Or even just to South Africa, which is where the closest data centers, like for AWS, are. Even that skyrockets when a cable gets damaged. So big problem. And unless I'm mistaken, it was last year or the year before that, I think we had 2 cable breakages, so we were basically isolated. It was really painful and, yeah, not at all conducive to having any sort of cloud native or, you know, really fancy technological developments. And we've got cloud service providers, sort of. There's only one that I'm aware of. It's called cloud.mu. So they do VPSs, web hosting, etc. But if you want anything like AWS, GCP, Azure, or any of those, it is literally an ocean away. South Africa or Indonesia, which are like the 2 closest ones ping-wise. And unfortunately, I don't think we're ever going to get those companies which have data centers in Mauritius, which would be really nice, just saying, because they've got really strict requirements like network redundancy. They can't afford that you lose a cable, you lose your connection to half of the world. Power redundancy, we've only got one company which does power, and space issues. You need minimum of, I think, 100 kilometers, 150 kilometers between data centers, and we don't have that kind of space. So the closest, yeah, South Africa, 60 milliseconds and an undersea cable away. Now, I'm bringing this up more like to share the culture, because here in Europe, I'm sure you all take for granted how you've got data centers all over the place, data center in your backyard, all of that kind of stuff. So we don't have that, and that's actually the basis for why we did what we did, which is a bit of I don't want to say shit post, but it is basically a shit post, but for tech. So the solution: the world is your home lab. Embrace it. So, as you saw, I have a home lab, and I thought, well, we have an island. The island isn't even that big. So what if we turned our island into a big home lab, or rather, a set of home labs? So, because the home lab at my place, it's really cool and all. It hosts sort of cool services, my website and stuff, really nice. But when I lose power, which is a bit often, then everything's down. No website, which is like really tragic for the 5 people who view it. And we all know the companies which have multi-cloud. So in case Google Cloud deletes your billion-dollar infrastructure, you can fail over to Azure or wherever else. So yeah, they use multi-cloud for better redundancy, for all those really cool perks. So we said, what if we do multi-cloud, but multi-home lab? So everything then would be orchestrated through Kubernetes. It would be basically a cluster which would span the entirety of the island. And it was a challenge. It was a lot of fun, and it's still operational today. So the plan. We are going to have at least 3 locations, i.e. 3 houses, not data centers. 3 machines at least per house, because that gives us quite a few nodes all over the place. We can throw workloads wherever we want. And they'd all be joined in one big Kubernetes cluster. So that's the base plan. That's what we want for redundancy, for that kind of stuff. So we use some cool tech. K3s, first of all, because it's lightweight, and I already use K3s on my home lab. I like K3s. Longhorn is going to do the persistent storage and replication for me. I've got Minio and S3 for backups, because backups are important. And for now, we are using Tailscale. And I'm going to get to why we use Tailscale, but it's basically used to connect everything together. Because we've got some 9 nodes spread across the island, different IPs, different ways of connecting to them. And so now Tailscale. But it's going to get replaced sometime soon. Some of the concerns which we had, it started with latency. Now, if you're going to do something like maybe just across London, which already is bigger than Mauritius, I think, you're going to have concerns with latency, because the default etcd heartbeat for liveness is timeout of 100 milliseconds. So any more than that, and now you're a bit in trouble. Then we've got power cuts. If we put the control plane in one place, then if you have power cuts, or we have cyclones and stuff at home, if something gets damaged, boom, out. We also have an inconvenience with IP changes. So our ISPs, they tend to rotate our IP every 24 hours. So in my case, with my single home lab, I just use DDNS with Cloudflare to update my IP. But when you're running Kubernetes with many nodes all across the island, and you've got to, orchestrate them all together, having the IP change every 24 hours is a real pain. So that's one of the reasons we went with Tailscale, because we don't have to do IP forwarding, DDNS, all those complicated things, which would have probably made our life a bit harder in terms of managing the cluster. And then bandwidth, because usually you're recommended for a Kubernetes cluster, you'd like to have gigabit connections, and I'm sure for you people it's like 10 gigabit connections. So thankfully, within Mauritius, we have really good internet within Mauritius, not outside. So we do have decent bandwidth. It's not too expensive. And actually, that's a really good advantage of within Mauritius, because the moment you go outside, you have really slow internet. It's not at all the same bandwidth. So, yeah. Okay, so in terms of production use, because the end goal was to use this for a small startup which wanted to, use Kubernetes and also drive down costs, because running things on AWS or the local cloud provider would have been significantly more expensive than just buying a few second-hand mini PCs, stacking them together, and just calling it a day. So we had to do some changes to the cluster in order to support them. We've added some exit nodes to Tailscale, because there are some nodes which aren't on the Kubernetes cluster or on part of the Kubernetes cluster, but that you still like to access, some of them like being IP cameras and stuff like that, we are considering installing Tailscale and Kubernetes on those cameras, but that's a long-term project. And there's some AI stuff, which I'm not going to get much into. We are adding, therefore, like GPU nodes, which have the added performance for AI workloads. So yeah, that's kind of like what the cluster is. And now's a good time to mention, I wanted to get rid of Tailscale because the issue with Tailscale is that it's got a control sort of server where all the traffic would pass through. The issue is that we don't have a server like that in Mauritius, and replacing that server with Headscale, which we could put in Mauritius, would give us a lot better performance in terms of latency, because right now we're seeing like around 50 milliseconds, which, I mean, we're on a small island. Between each of our houses, it's like 1 to maybe 3 milliseconds. So we'd like to make the most of that and then replace Tailscale with Headscale, get lower latency, and then we can see about scaling up on the whole cluster. Wow, that's the end already. Done. Okay, if there's anyone who's got questions, because I wasn't expecting it to go by that fast. Sorry. No questions or about like the structure? Yes. Okay, that's an interesting part actually of the way we're doing it. One of my ideas in the future is to have the control plane on the cloud provider, cloud.mu, because then we'll have the advantage of it being in a data center, having UPS and all of those extra facilities, which I don't have at my place. Being on a cloud provider means that I do have external IPs, public IPs, which then I can direct the DNS entries for the website can go there, and it ingresses into the cluster through Tailscale. Yes?
Was the reason for Tailscale just simplicity, or were there more advantages over plain WireGuard?
I think plain WireGuard, it would have made my life a bit, you know, it's just for, we wanted to play around with it. But we went with Tailscale because, well, first of all, it is fairly reliable. And the other issue being, if we've got 3 nodes in one place, we're wondering, well, how are we going to make sure that the traffic, because we only have one public IP now for 3 nodes, how are we going to make sure that the traffic goes where it's supposed to? And also, unfortunately, we don't have IPv6 in Mauritius, so that's unfortunate. Yes? Yeah, you. Thank you. Thank you. Yes. Yeah.
But given the rough situation that you guys face in your island, how do you foresee, for example, if you need to scale that structure, like adding more node clusters or whatever? How do you see that?
Okay. So how would we scale, like, given the rough situation that we have? Get more friends who are willing to host machines in their place. Like, that is the best solution. It is fairly scalable with Tailscale because it's just one IP for as many machines as you want. Oh, sorry, it's not one IP, one public IP, as many machines as you want. But we can find more locations. Unfortunately, something actually I should have mentioned is data center costs are astronomical. If you want a little bit of rack space, even in a shared rack, that it costs a lot. Like, I'm sure by your standards here, it probably wouldn't cost that much, but, you know, we're poor Africa. So yeah, scaling, get more machines, throw into the cluster through Tailscale, and fingers crossed it works. So that's our approach. Yes.
Do you have any solution for like image distribution, things like that, if bandwidth is limited?
Okay, for bandwidth. It is not incredibly limited. We've still got like upload, download, like we've got 200 Mbps, well, at least that's my home plan. So it's not awful, but I do have my own Docker registry where we push things and then we can consume the images straight from there. So already the fact that I've got some nodes at my place, which is the same place as the registry, it's fast enough to get the images across. Yes. Thank you.
mindset. I also went to Mauritius once and know that La Réunion is somehow like an internet exchange point and driven by, of course, somehow. Maybe I didn't get it in the beginning. Okay.
Yes, La Réunion is right next to us. So we share a few lines, like the Métis one, the blue, and the other one which brings us to India and Indonesia. So yes, we're shared.
Okay, so you just, the next stop would be La Réunion and from there, or you clearly do have a direct connection there?
Yeah, actually, then in that case, yes, we would have direct connections to La Réunion. And it wouldn't be that bad because neighbors, so yeah.
You were talking about having friends or doing cooperations like to La Réunion. Maybe it's better to just strengthen this connection than having distributing geographically data center there and Mauritius. Would it be possible?
Oh, you give good ideas. That's actually that's actually a really interesting idea. I've got to find people with enough money. We're going to make a data center in each place and then link it and then get cloud providers to come. Although I'm not sure they'd appreciate it given that there's those cables between us. I'm not sure. That's an interesting question. I've got to research that. Yes.
So how big is the community of cloud people, like-minded people like you on Mauritius and maybe also on La Réunion?
Okay. Question was, what's the size of the cloud, specifically cloud community in Mauritius and La Réunion? La Réunion, I can't say much. I haven't been there. In Mauritius, we have Cloud Native Mauritius. I got a message from someone saying we're watching you from back home. Okay, the size. So Cloud Native Mauritius itself is 50 members. It isn't big, but it is significant at least for a part of the world, which I'm going to say is not adapted, not evolved into the cloud native world yet. We do have meetups fairly regularly. The last one I think had 15 attendees. So that should give you a scale of, it's not like KubeCon or Rejekts size big. We do have an annual developers conference, which is like the biggest tech event. And that one, I think last year, I forgot the number actually, it was like 1,600 people. So we do have a really lively community. It is a significant number, especially for a small island. So we do have a very vibrant, very active community. Just in terms of cloud native, we're trying to indoctrinate them, you see, so gradually. Yes?
How about security? How do you take security into account? Like, it's really cool what you've been able to do, but how do you, especially with fintech and entering into that space, how do you approach security?
Okay, how do I approach security? Do you mean security for like my cluster or security like... All my friends. Okay. I'm debating right now whether to slander people back home or... Yeah, they're watching me, but the government isn't. If you look at certain government websites, you will see that priority is not their first concern. I'm going to say that. For a lot of like the banks in Mauritius, we have, I mean, I'm sure they have their own way of doing it. Insurance companies have, the one I worked at for a while, when I worked at for a while, they had their servers in-house. So at least there's that. Another bank I know of, they have servers on AWS, especially given that the government's given a bit the green light for doing stuff on the cloud. I can't say what they do specifically for staying secure, but...
No, I'm just curious how you, like when you're designing your system, or when you're designing, how important is security into that? Like, that wasn't specific.
Right. I assume that the banks, insurance companies, and big companies, they have stuff like that. But I think the general trend is that security is an afterthought. For most people, it's, yeah. Yes.
So, this is kind of a small island. How difficult it is for you to acquire hardware? What kind of hardware are you running on, and like, can you order a server and GPUs?
I love your question, because that is a serious problem I have as a home labber. The stuff in my rack, most of it comes from here, from the UK, and I get it shipped all the way because it's cheaper to get it shipped from here, paying here and everything, than it is to buy used hardware, even second-hand hardware back home in Mauritius. Servers, expensive, because they're big, you got to ship them. Servers, expensive. Oh, and networking as well is very expensive if you're a business. Like, if you need, like, the resilience, you know, to keep on functioning, you know, if you've got issues on the cables, they're very expensive. I don't remember the exact numbers. My boss at home, he knows the numbers and they're not pretty. So servers, not cheap. Racks, not cheap. Like I saw here, you can buy racks because I want a 42U rack in my living room. I want one of those, but the problem is it's very expensive. Here you can buy something used off Facebook Marketplace. So what does a current cluster run on? A mix of Dell Optiplex micros and Lenovo Think Centers, those really tiny boxes. We're talking about like i5 4th gen.
Yeah.
Do you feel privileged? Yes, I think I have time for one last question.
Okay. Yeah, thank you very much for a great talk. I was just wondering if you have, like, you said 200 megabit connections between your houses. So how well is Longhorn performing over that?
Longhorn performs surprisingly well. Of course, I can do stuff like data locality if I really want the extra performance, but I've seen that replication and all that kind of stuff, even across our different locations, it isn't that bad. And especially once I've got head scale installed to replace tail scale, then I assume it's going to be a lot better, a lot more performant, and a lot more stable. Because as I said, it's like we decided, let's do a home lab but across the island. We didn't initially think it was going to be like that serious, but well, here we are, and here I am. Okay, yes? No. A funny story about that, actually, I'm getting more slander on my country. Last year there were elections, and then the government asked all ISPs to ban social media for like 24 hours. So I guess that kind of shows that Starlink would have been nice, but that wouldn't comply. You know, you got to get through the compliance with the Information Communication Technology Authority and stuff like that. So extra loopholes. And small country, I guess we're a bit of an afterthought to big companies like that. A lot of people are looking forward to it, though, I can say. Any other questions? Nope. Yes? Cool. Thank you very much for attending. Apologies, the session itself was a little bit short, but the questions afterwards are really fun. Thank you very much.
Hello guys, welcome to this session, and I hope you did enjoy the presentation so far. And today I'm here to speak about metrics and metrics for platform engineering initiatives. My name is Graziano. I'm Italian, as you can understand by my name. I never thank enough my parents for giving me this ugly name, but anyway. I'm a developer relation engineer at my platform. I joined the company 2 years ago, and I had the opportunity to see many company trying to understand how to measure their platform, how to measure their platform adoption. And a frequent question is, how can I measure the platform impact over the business outcome? And that's actually what I'm trying to give you the way to answer with this talk. I know that most of you are here to listen the answer to this question, how I can measure my platform initiative success. But before trying to understand how to apply the frameworks we have on the literature, we probably have to understand what. So basically, how we can apply frameworks if we don't know what we have to measure before, which is the scope of the things we have to measure. So first, why we need metrics? The reasons are basically three. The first one, we need metrics. We need something that help us to prove the value we bring to with the platform. We put a lot of effort and investment to build the platform, and we need something to prove this value, prove the value that we bring to the overall organization. And this value can be measured by the platform metrics. The second one, we need metrics to get the buy-in from the higher rank of the stakeholders. There are a lot of success reports out there, but they are not enough to justify the investments in terms of people and money to build a platform. I don't know if you try to go to your boss and said, okay, I need a platform because I read an article online. Good luck. And the last one is to drive further improvements. We build platform on an iterative feedback loop made by evolving TVP. We build a TVP, a tiniest viable platform, and this becomes the foundation for the further improvements of the platform. So we don't need metrics just to know that we did something good. We need metrics also to understand what we can improve and to drive further enhancements for the platform. So maybe the first question to start is not how, in terms of which frameworks I can apply to measure the platform, but what is the scope of the things I want to measure. And to understand the scope of a platform, we have to start by understanding the process that we embark to adopt a platform. It is actually not a standardized process, and it is most of the time unique because you need to tailor the platform over your needs. So to give you just an example, basically you may start to recognize the need of a platform because you see a sort of wall between the developers and the ops team, where the developers are forced to wait for the ops team to give them access to the infrastructure they need. So you start to build a platform to escape this so-called ticket ops trap. And you need a platform to provide them a sort of self-service capability that they can use to get the infrastructure they need in a self-service way. Then once the developers are onboarded on the platform, you may start to recognize the value of the platform by trying to implement something more wider to enhance the developer experience for the developers. So it's something wider than just self-service capabilities for the infrastructure. You start thinking about paved paths that are more wider than just infrastructure and comes in forms like templates or libraries or something like that. Then once the developer experience is enhanced thanks to the platform, the organization may start to recognize that working on the developer productivity often lead to business improvements, benefits from the business side. So the focus scale even further with the aim to accelerate even further the time to market. And at the end, it works to standardize all the process. During these 2 years, even if the adoption of the platform is strongly tailored by the company who embarked this journey, we recognized a sort of recurrent pattern. The first one is that the need of a platform is basically driven by a need to have a self-service capability to provide infrastructure and automation to the developers. And it's actually important to understand which phase you are in when you are trying to set metrics, because each phase comes with different complexities. You have to balance your metrics on the phase you are. So basically, when you work on the first instance to provide self-service infrastructure, it's important to understand under a technological point of view what you have to measure, because you need a clear view of the pain points for your developers. In this way, you can provide just what they need without waste time and money. Then the platform usually evolve, and the shift focus from the automation of the infrastructure to the developer experience. This way, the developers are mostly onboarded on the platform, and in this phase, is important to have a look at the adoption of the platform, because you have to know which is your market, your population of developers that are already on the platform, and which is the potential market, so the developers that are not on the platform. And you have to look to the developers to understand what you need to provide them in terms of developer experience capabilities. And I think that is important is to look at people, because the most common cause of failure for the platform is to focus mostly on the technology, build a lot of abstraction behind using the most advanced technology, but basically if the developers are not on board into the platform, you risk to waste your time, because actually no one uses what you built. The last one is where the focus is shifted, and is shifted even further, and here the target is the business. The platform is recognized no more as something that you can consume passively, but a sort of collaborative tool where developers not only use the automation provided by the platform, but they started to collaborate with others and establish a sort of circular economy of software inside the platform, so that what is built by a team is then put into the platform to be reused by others. And in this phase is important the role of the platform team to curate all these processes and make sure that the process is as seamless as possible. We try to map all these processes into a map that shows a typical process to embark in the platform adoption, but that's not the point for the talk today. What I added this image to the slides because I want you to think about that the platform is actually a picture of the organization, okay? And you have to do a zoom out in terms of the capabilities you are looking for. If you watch the image, the purple cells are the commonly recognized capabilities for the platform, but actually you have to zoom out from that to see the overall picture, where it started from the very beginning with infrastructure modernization, and you have to have clear in mind what are you build in terms of business benefits. In this vision is simple to understand that we not only deal with technology when we are talking about platforms. Technology is important because we are build something for engineers, but technology must be also adopted. And to adopt something, to make others to adopt the technology, you have to make as seamless as possible the process to use what you build. So the developer experience is also important. Then we also have people. We deal with people, of course, and introducing a platform into an organization often requires change in the organizational paradigm, okay? Look at team topologies, for example. And you have to build a relationship with your people, and you can't just impose new processes with the hope that they are following them blindly. Of course, then we have two other aspects. The first one is architecture, because you start building your platform to fit your current architecture. But when your platform is set up, you have the opportunity to evolve this architecture even further. And last but not least, we don't work for the glory, so we have to translate what we did in a technological way to business outcomes, of course. So even the business must have clear what we are doing and why we are doing that. So it's clear that we can take a framework available on the literature like DORA and apply it to measure all this stuff. We need to understand what the literature tells us, so we need to understand what is DORA, but we have to take what we need and tailor it to our needs. So let's start understanding the mindset we need to set the metrics. First of all, most of the time, you start setting the metrics after you understand what you need in terms of capability. The first thing I want to present in terms of setting the metrics is that you have to incorporate the metric choice into the process where you define what you need and how to build to reach your goal. So first of all, you have to have clear in mind which is your goal. You want to build something in terms of automation for the infrastructure. Maybe in this situation, focusing on how fast is the pipeline to deploy is not the best metric to have. Then, once you know what you want to build, you have to plan and prioritize your capabilities. And last, you have finally the how. So you have to choose the metrics. And the first metrics you have to use is the metrics you have already in use. So basically, you started to recognize the need for a platform, I hope in a data-driven way, not because you wake up and, hey, I need a platform. So basically, the first metric to use is use what you already have. And then you have to look at the market of frameworks and takes the minimum set of metrics you need, trying to find the balance between having a lot of metrics and having not so enough metrics to understand what you are doing. So to summarize, I learned about 3 pillars to set the metrics. The first one is that the best way to define new metrics is not to define them all. Instead, the first approach to measure what you are doing in terms of platform, but even in terms of any other initiative, is to start by measuring the impact of the platform, of the solution you are proposing with existing metrics. And then we will see also why. Then you have also to take into account the interest of the different stakeholders involved. We are not talking about platform engineers and developers. It's a wide range of people involved into the platform. And you have to consider all the key aspects they are interested in to set your metrics. Last, you have to outline the metrics so that you have progress metrics that define the progress in a technological way of your platform to outcome metrics that identify the business value you are bringing to the overall organization. In this way, you have this link in a clear way and you can explain better why you are building something. First point. The usage of existing metrics. Basically, as I said previously, I hope the decision process is always based on a data-driven foundation. I can't imagine an engineer that wake up in the morning and say, hey boss, I need a platform. And the answer will be something like, oh, did you buy a train? Why you need a platform? You need basically the metrics that let you understand that something is not working. So when you find a solution to solve the problem, if the metric doesn't change, if the context doesn't change, and the only thing that actually changes is your solution, you can isolate the problem and evaluate against the context in which the problems arise in the first instance. Then we have to look at the specific platform personas. And as I said, we are not just talking about the platform team and the developers. It's a wider range of people. And to understand who they are and their interest, we have to talk about, we have to have a look at how the platform is consumed inside the organization. At the beginning, we have the owners of the effort, the platform engineers. They are actually building something that is important under a technological point of level. They are building technical systems. So the first metrics they are looking for are metrics that can measure under a technological engineering and technological point of view this effort. Then they are looking for also to metrics that define, that help them to understand how the platform is adopted inside the organization. So the first two set of metrics that are important to us are adoption and engineering metrics. Then we have the product teams. Actually, our internal clients, if we want to speak in terms of platform as a product. So they are likely to use the platform if the platform itself makes their life easier. So the metrics that are important to them are the metrics related to the developer experience. On the side, we have the internal stakeholder, the so-called stakeholder that have the power to sponsor the platform or to abort the initiative, and they are looking to metrics related to the business, okay? They want to see clearly how what you are doing in terms of technology is impact the business outcome of the organization. At the end, of course, we have the end customers. They probably don't know nothing about the platform. They don't know that the product they are building is built using a platform, but I think sure they care a lot about the reliability of the product you are building. So you have to incorporate also reliability metrics into the platform to understand how you are working and your success. Let's come to the metrics. Let's come to the frameworks. I added just 3 frameworks. There are also other frameworks that you can use to measure your platform, but it's just a brief look at what we have in terms of literature. I want to talk about Dora, Space, and Monk, which are 3 frameworks completely different from each other, and that each of them is built and refined over the years to serve a specific purpose. The first one is Dora metrics. Everyone know about Dora metrics. These are the North Stars for a lot of DevOps team in the space, and they basically aim to measure 2 aspects: the velocity of what we are building and the stability of the outcome we are producing. About velocity, they are based on 2 cornerstones. The first one is deployment frequency, so trying to measure the number of successful deployment that we do in production, and the lead time for changes, so the time, how long it takes to write the code and put it into production. From the other side, so the stability, we have 2 pillars. The first one is the change failure rates, how often deployment brings to failures in production, and how fast we are to recover from these failures, which are the median time to restore. The other one is Space. This framework is particularly useful for the developer experience side of the platform. Is younger than Dora. I think it was developed in 2021 or something like that, and it is an acronym of the aspects it aims to measure in terms of developer experience. In fact, we have 5 different areas, which are the satisfaction. So the first thing it want to measure is how fulfilled, healthy, and happy a developer is about its work. The second one is the performance, so the measuring the outcome of the process in terms, for example, review rate, customer satisfaction, or reliability. The third one is activity, so you are measuring the count of action or outputs. Then we have the communication, so measuring all the stuff involved inside the communication processes between teams, and the efficiency in terms of quality and quantity of uninterrupted outputs that the developers can produce. This is in terms of context switch, for example. The last one is the less known, I think, in the engineering space, because it's Monk. It's not engineering related, it's more about the market analysis. And this is also another acronym, and stands for market share, onboarding time, net promoter score, and key customer metrics. Why we need Monk? Monk is particularly useful in the context of platforms to measure the adoption. Monk helps us to have a focus on the market share, so the number of developers who are using the platforms, the onboarding time, so we have to take care about the experience of the developer using the platform, and then the net promoter score, which is how likely the developers are to suggest the solution to other developers. So we have these 3 frameworks. We just need to take these frameworks and apply them blindly. No, because we have to tailor what the frameworks tell us to what we are trying to build. And how we can do that? We can do that by connecting the dots. So first of all, as I said, have clear in mind the goal. You have to always keep in mind what you are building. It doesn't matter if it is something for the automation of the infrastructure or to improve the developer experience. You have to set the metrics based on what you are building. The second one is to understand how the platform personas has impacted. Everyone in every phase of the platform adoption have interest in your platform. So it's wrong to think that if you are in the initial phase where you are thinking about automation, infrastructure automation, the business is not impacted. You have to provide the whole picture. The third one is the usage of the frameworks itself. You have to know the framework we already seen, and you have to take what you need from them and try to apply this to the persona's viewpoint. I talked about the business, and I said that the platform is the picture of the organization, and this is actually true. And if the platform is the picture of the organization, the metrics you set must tell a story, and this story must be connected between the low-level personas, so the platform engineers, to the business one. And the best way to do so is to have in your bucket both progress metrics and outcome metrics. Progress metrics are the most simple one, which are the metrics that quantify the value of your platform. And then the outcome metrics are those that measure the impact of the platform over your business outcomes. Having both help you to demonstrate a correlation between engineering productivity and business outcome, making a clear picture of the story you want to tell in terms of how the platform is beneficial for the business. Look at the image, for example. We started from an adoption metrics, so on board 80% of the product portfolio on the platforms, and we want to link these metrics to the business one. Business is looking to improve the time to market by 20% year over year. You have to find a domino effect where, starting from the adoption metrics, arrive to a DevX metrics. So having the 80% of the portfolio on the platform, reduce the 70% of the ticket of the ops team, making the deploy cycle even shorter, and increasing the reliability of the system so that the developers are faster in delivering value and the time to market is accelerated. Last but not least, we talked about the goal. It's important to have in mind the goal. And to do so, we have to start from the strategic objective of the company. We can split the strategic objective of the company in 3 different levels so that they are affordable to understand and to work with. The first one is the enterprise level, is the higher. The second one is the portfolio level, so the translation of the enterprise level to topics more close to the product team. And the last one is the team level, so the lower level where the targets are not the wide organization, but the single team. We have to start from this strategic objective, set the platform objective, and starting from this platform objective, we can define the metrics. We've ended the time, so now it's time to recap the takeaways of the session. First one, escape the metrics traps. If you don't know which metrics you need, don't add any. The best way is to measure and evaluate the solution you are proposing with the measure you already have. The second one, take always care about the people that are using your product, in these terms, the platform. And then try to align progress metrics with outcome metrics to give the whole story to the people who are reading the metrics. And the last one, when you are setting your goals, start by defining the metrics from the wider objective for the organization, from the strategic objectives. thank you. If you have any question, I'm here or around the conference. And if you want, here you can find some other articles where I talked about this kind of stuff. And my written English is better than my spoken, so maybe it's clear. Thank you.
Thank you, Graziano. We've got time for maybe one or two questions. Anyone with a question?
That's one.
One here. Here we go. Can I pass you the mic?
Hello, Graziano. I think it was a good talk. One of the biggest problems I've found when I've done what you've done as well is the cultural issue, which is a lot of the times people come in with, here's a solution, can you go and implement it for us, rather than here are a load of requirements, can you work with us to solve them? How do your metrics help solve that problem? Do they say anything about that at all?
So you are basically say that your customers or the team comes with the solution and not with the problem, right?
Correct, yeah, they'll say, oh,
Okay.
can we have another three-node Kubernetes cluster, for instance?
Okay, basically, maybe the problem is not about metrics, but it's more about how you dialogue with these people. I showed you the map in the 5th or 6th slide, and we actually built it to sit on the same table with our customers and talk together about what they want to accomplish in terms of I want to arrive here. So they are basically tell us what they want, not what they think we have to do to arrive there.
Correct.
So basically, I think that before start to talk about metrics, you have to try to establish a sort of dialogue in different terms with the customers. Maybe the metrics can help you, because when they come with a solution, you can ask, okay, you have a solution, probably you already thought about the problem. Can you show me the metrics, the measurement you have to support, to notice this problem? If they don't, there is another problem. You can start talking about that, talking from that.
Yes, good. That's a good point. Thank you.
Maybe.
Often the problem that I have with, by the way, love the talk, but I've been told to keep it short and snappy. The problem that I found with metrics is Goodhart's law. Any measure used for social control ceases to be, or any measure which becomes a target ceases to be a good measure. Effectively, you have people trying to gain metrics, I guess the question I'm trying to get at is how do you avoid the gamification of metrics, or how do you avoid people trying to effectively work around the metrics such that their number looks bigger or their result looks better, as opposed to the metrics, which causes the metrics to stop being an accurate reflection of the platform?
Okay, if I understood, you are asking me how to avoid that the metrics become the objective, so that the people work just not in terms of goals, but in terms of someone said, I have this threshold, I reached the threshold, that's okay. Probably this is also a problem related to the culture. Because if the people who are working with you think in these terms, probably you can't do something about how you set the metrics, but you have to try to make it visible that the metrics are just a tool, a mean to understand the impact of what you are doing. That's not the objective. You have not to set thresholds that, okay, we are reached the threshold, we are happy, let's go on vacation. Okay?
Yeah. And I think we'll have to leave it there. But thank you so much, Graziano. Okay. Please, round of applause.
Thank you.
And you can find him around the conference. Thanks again.
right then. I guess we will get started. Okay. Thank you for coming to this talk, and welcome. We're going to be talking about Cilium at scale for running a number of different workloads, mostly ML. Luigi?
Oh, yeah, well, thank you for coming. My name is Luigi. I work as a senior Kubernetes engineer for a company called G Research. If you haven't heard of us, we are a quantitative research and technology firm. We're based in London. We have some offices as well in Dallas. And, well, we try and use some of the most recent technologies, such as machine learning and big data, to predict financial movement. And here I have with me James.
Hi, my name is James Laverack. I'm currently a Principal Customer Success Architect at Isovalent at Cisco, which is a long title. I've been in and around the Kubernetes space for a little while now. I'm an ex-release lead for Kubernetes itself, and I'm also the co-author of an upcoming book about Cilium I'm running. Yeah, I suppose I'll start just by kind of talking about Cilium a little bit. So Cilium is a CNI solution for Kubernetes. It does a number of other things as well. This talk is not intended as like a first principles introduction to Cilium, and it's also not a technical deep dive. So the point of this talk, just to set everyone's expectations, is kind of real world stories for things that we encountered and that went wrong, basically, and how we fixed it.
Yeah. Well, so me and James have been working on bringing Cilium into our, well, G Research infrastructures. We worked over the past year to, well, run it from a few hundred nodes to now tens of thousands of nodes, with some of those clusters, well, reaching numbers over 1,000 of nodes in size. Yeah, and then these now run fully in productions. We are hosting mission-critical applications for G Research. And yeah, well, we've been running it out quite successfully so far.
So just give a quick overview. Luigi's going to give a quick bit of context for our deployments, kind of so you can understand the kind of system we're running and the scale we're running at. And then we've got 3 stories. We've got one about map pressure, one about contract, and then a little bonus story that happened a bit more recently. And there's a little flavor about some of the problems we encountered. I do have to give a quick disclaimer. So this is an open source event. Cilium is an open source product. In production, they actually run an enterprise version of Cilium made by Isovalent. Everything that we are talking about is fully in the open source version. So everything that we're doing is open source metrics, open source solutions. So yeah, there's no vendor pitch here, if you see what I mean. Just a quick disclaimer for you.
Yeah.
Luigi, why do you run Kubernetes? How do you run Kubernetes?
Well, right. We have quite a big high-performance computing environment that runs entirely on-prem, air-gapped, deployed on top of our private cloud. We run Kubernetes directly on bare metal machines. These are owned and operated by G Research. And while we deploy pure Kubernetes, pure upstream Kubernetes, we don't make use of any distributions. And well, yeah, rely on fully custom automations framework that we built from scratch. Mostly really because we built it ahead of time. I think we're talking about 5 to 6 years ago, maybe a bit more. Next slide.
Sorry, I got it.
Oh yeah, no worries.
I got it.
So yes, well, what do we use Kubernetes for? Well, among many different things, we run Kubernetes to operate our CloudFarm, which is essentially large-scale clusters with thousands of nodes. We run a diverse mix of workloads, and some of these can run for a few minutes, others run for days, which sometimes can be quite challenging for us. And currently, our CloudFarm, processes over 4 to 5 million jobs per day on average. Heard as well, we sometimes peak at 11 millions, depending on the days. As a side, we do use Armada, by the way. If you haven't heard of it, is a scheduling systems that we have developed and donated to the CNCF foundations. You'll find us at armadaproject.io in case you were interested. I'm going to talk to you about some of the challenges that we have to tackle. For security and compliance reasons, we have to segregate certain workloads based on the type of data that they use. Initially, in G Research, we tackled these by run entirely separate physical network, separate compute infrastructures, and we had, of course, different Kubernetes clusters for each level of segregations. Well, these we found out quite soon that it was quite hard to maintain. It was very inefficient as well. Every changes that we had to do, we had to, well, roll out multiple times. It adds to the challenge as well the fact that some of these environments you could only access from specific locations. So we now run everything in what we call merge clusters. And we use, well, network segregations at the namespace level with things like network policies from Cilium. It's about thousands of namespaces, all isolated from a networking perspective. And this helps us, you know, maximizing hardware utilizations and meeting our security requirements. Well, the setup introduces quite a few layers of complexity on top, and some of these we have tackled now with Cilium. And we'll cover some of the topics, well, some of these topics we'll cover today. Just as an aside, I wanted to kind of explain why we're using Cilium, why did we pick it. Essentially, we just really like it. We think it's quite, you know, the observability part of it was really, well, what at least caught my attention. And then as a company, I'd say we really are trying to future-proof ourselves. We're trying to build the technologies by looking into how things will look like tomorrow. And well, we believe that eBPF-based networking in Kubernetes is the future. So that's why we decided to go with Cilium.
So that's the what and the why. So let's talk about everything that went wrong. So first of all, we'll talk about map pressure. So to set the scene here, we're scaling up from a couple of hundred to about 1,000 nodes over a space of about a week. I live in Bristol, so I work remote, but for this I have gone on-site into London for a few days in order to help support this. So I'm in their offices. And I get in about 9:30 a.m., which is when we start. And before we do anything, before we want to add any more nodes, we think, let's take a look at the metrics for what's running there now and see how things are.
Oh, yeah, so first thing we see, not exactly something I was expecting, a huge spike in, well, Cilium operator error. And yeah, that number is true. We just saw 110,000 error per second.
On map operations.
Yeah, on map operations.
We'll get to in a second what that means. We also look at map pressure. We can see that map operations are having problems. So the map pressure, as you can see, for most nodes is now at or over 100%, which is not good.
Yes, and well, this was not a new problem. I did observe these over the past few days before that. It just seems much more stable than I thought. And you can see here, in fact, overnight, it was actually dying down and everything started to look a lot better. So by the time I went and had a look at these, I really didn't have my coffee yet because I did not expect these to blow up so suddenly. So yeah, as you can see, about 9:30 in the morning, yeah, things just decided to explode. And I really should have gotten that coffee.
Yeah, it was a fun one. It's a fun morning. All right, so as a very quick side note for those less familiar with eBPF, you might wonder what a map is. It's effectively a generic term for a data structure in kernel for eBPF. When you think map, if you're a programmer, you might think this is like a key value map. They're not always like that. Some of them are. Just think of it as data in kernel. And Cilium uses these for all sorts of stuff. It uses it for policies, contract, just about everything you can think of is a map in Cilium's case. So you might wonder what map pressure means. This is just how full the map is in a percentage. So at or potentially over 100%, which I think is just a measurement error, is bad because that means the map is full and it can't fit any more elements in it. So we thought, well, we're seeing some maps full. Maybe we can just fix that by making, what do we think? Make the maps bigger?
Yeah, absolutely. Yeah, that's exactly what we tried. We looked at a few settings that we could maybe tune. So we found one called map dynamic size ratios. So we increased that, well, from 0.025 to 0.1, but that unfortunately did not help. And I like to stress the fact that I didn't have coffee yet because we found out later it was a different settings that we should have tuned.
Yeah, wrong setting. Didn't do anything.
Yeah, but yeah, at the time we unfortunately did not know.
Which brings up an important point. There are different maps from Cilium's perspective. Which one was full in particular? It was the policy map. You might wonder what this does. So every pod on a Cilium managed node has a policy map. And this actually is like a sort of key value-ish thing. that describes for kind of other identities, so other things in the cluster, and like protocol and port and things like this, whether it should be allowed or not. And the consequence of this being full is that if you made a policy change, so you added a new Cilium network policy, or you launched a new pod that got a new identity or something, then that change might not get propagated to the data path, and therefore it might not be fully in sync. So this means you could end up with things being allowed that shouldn't be, or things that block that shouldn't be. That there was no guarantee that policy was going to be in a consistent state from here, which is, of course, you know, pretty bad.
Yeah, so why, I guess, the map was full. Just to give you, before that, a small recap. We have about 1,000 namespaces in our Kubernetes clusters, maybe a bit more. Security for us is enforced at the namespace level, and so we deploy one Cilium network policy per namespace among other cluster-wide network policies as well. So we have about 1,000 network policy objects among all of them, but that many policy is not really an issue. Otherwise, we would have seen it, I guess, in the open source world. So why exactly was it full? And it was at that point, well, that James kindly asked me what was these clusters about, what we were using it for. And yeah, I just answered, yeah, it's Armada. It's a job scheduler. We just submit a lot of jobs.
So what this meant in particular, when we took a bit of a closer look at things, was what was happening was Armada, for its own reasons, which make a lot of sense, puts a label on every pod which is effectively unique on every single pod. And so I brushed over this earlier, the idea of identity. So Cilium has this internal concept of identity. So when you say you're allowing traffic from a certain location, that's tracked as an identity. Cilium generates these identities dynamically from the labels on the pods. And if multiple pods share the same labels, they share the same identity from Cilium's point of view. So what happened is that every single pod had a unique identity, and because we were selecting each namespace in each policy, that meant that every single pod had a policy map which listed effectively the identity of every single other pod as an identity. So we ended up with like an n squared problem going thing. So what happened here is the default policy map size is about 16,000 slots, and we had gone over 16,000 pods, which is why everything just went into a horrible disaster meltdown. So that's what happened here.
So what did we do to fix it? Really, the fix, after we understood the problem, was quite easy. Cilium allows you to set, whichever labels you need to create identities. So what we did was essentially exclude all the Armada labels that did not make sense for us and limited only for the one we were sure of. Essentially making sure there was a one-to-one mapping between a namespace and an identity. This is how it looked after. Everything was way better. Actually, you can't see it very well here, but these are not even the same map that we were looking at. These are completely different maps. I think these are contract or global
Those are contract maps, yeah. Because this dashboard was showing like the worst map on each node, and it was no longer even policy. Because it just fixed it immediately.
The problem essentially disappeared. And well, key takeaway, so we consider already namespace to be the security boundary. We just didn't tell Cilium. So after doing that sort of things out.
So that was a fun morning. So our next problem that we kind of moved on to after this was around contract. And I'll have to explain contract in a moment, but bear with me for a second. So what we started seeing when we looked more into metrics is a high CNI error rate. So we noticed that we were getting errors during CNI deletes. So this is when you remove a pod and the container runtime tells the CNI to delete its kind of network information. And we saw an uptick in errors. We unfortunately didn't take a screenshot of this one. And when we had a bit of a dig around, we noticed it was failing sometimes, but not always, which is the most annoying kind of bug to find. So we dug into the agent logs, and we found things like this. So if you take a look at that, we can see an endpoint delete request come in, then nearly exactly 10 seconds pass, and then it tells us that it's ignoring an error while deleting it, And there's been an error message there giving us something about proxy redirects and context deadline exceeded. And then it immediately just removes it anyway. These are the kind of errors that we're getting. We're like, okay, that's a bit strange. So we dig into this a little bit more. Like, what on earth does this mean? You know, context deadline exceeded is like a timeout of some kind. And we dig around in the metrics some more, and we find out that the data path contract GC duration seconds was hitting about 10 seconds, which seemed suspiciously convenient with this 10-second timeout we were doing. So we dug around in the code a little bit, and sure enough, we found out that you can trigger a contract GC if in the event of a CNI delete. So here I'm actually going to tell you what contract is. So this is short for connection tracking. The general idea here, and this is again something that's implemented in eBPF in Cilium, is that we being Cilium, keeps track of traffic going out so that the reply to that traffic can come back in even if it wouldn't normally be allowed by policy. And this is true of both UDP and TCP traffic. So that's the general idea. We maintain a eBPF map pen node for contract, which is indexed in by IP. You might also wonder what garbage collection is. In this context, the GC garbage collection is this contract map is only so big. And so we have this idea of a garbage collection, which is a periodic process which will run, and it will remove all the old stuff. So this is either pods that don't exist anymore, or connections that just were so long ago we no longer care about the reply because it's clearly not coming, things like this. So we started digging a little bit more into that and taking a look at what metrics we can see there. And we could see that most of the time the contract GC was fine. Like you can see the quantiles on the top, and the P50 is under a second, and the P95 is about 3 seconds. But the maximum time, you can see in that bottom graph, was hitting between 10 to 20 seconds. Which meant that very occasionally it was spiking up really high, and then it was timing out.
Yeah, so what do we know so far, right? Well, contract GC seems to be triggered now on CNI deletes. Most of the time, it was fast, but even under within the 95 percentile, it was under 3 seconds. And sometimes, very rarely, it was taking more than 10 to 20 seconds, to complete. Which, when it occurred during a CNI operations, of course, was causing CNI error. At which point we started to dig a bit more deeper into the logs. And this is what we found, finally. There was essentially a garbage collection interval that was being recalculated dynamically. You can see here the actual previous interval was about 4.5 hours, and the next one was somehow calculated to be 7 hours into the future. So, what we decided to try and do here, kind of a hunch, we decided to tune the dynamic GC interval. There's a settings again for Cilium to set this up. So this means effectively that we keep this dynamic behavior that Cilium has to do garbage collections for the contract, but we set our maximum interval, in this case, to 10 minutes.
And that's just an arbitrary number we picked. We just picked a number and went for it.
And this is how it started to look like after we managed to roll out the change. At the 95 percentile, you can see it managed to go from what it was before 2-3 seconds to about half a second to a second. And then, everything else stayed the same. You could see as well that in terms of the singular measurement, the GC durations was, again, coming down. Pods that were using, taking more than 10 to 20 seconds to run the garbage collection started to, take a normal amount of time.
So our key takeaway there is really to keep an eye on contract. There are a lot of metrics that are exported about how long this is taking or how big the contract table is. And especially where you have lots of traffic, or if you have workloads that have kind of spiky traffic profiles, it can be a good idea to keep an eye on this just to make sure that things aren't starting to get a bit out of hand. Because if we'd been paying attention to contract before this point, we would have caught it before it started erroring out CNI deletes, for example.
Right, time for a bonus story. How to make Cilium use 1 terabyte of memory. How do we do that, I guess? So this is a much more recent story. It happened on a newer version of Cilium. And we're talking literally about, I think, a month ago, I would
Like
say.
a month, yeah. So.
Yeah. So we were deploying a fix, a memory issues that we saw actually for an enterprise feature we were using. Well, we were confident that the fix was working, but after a rollout, we started to see the memory climbing.
So this is what we saw on the dashboard. This was pretty fun. So we can see this is Cilium agent memory usage. Hitting a terabyte on the worst nodes. The CPU usage, interestingly, is not that high. Remember, that's like percent of a CPU core. So like this is not that high. So we're seeing a bit of a strange set of things. We're also seeing this rather weird behavior where it starts off quite slow and then builds up over time, to the point where one of Luigi's colleagues actually asked on a call, you know, what language is Cilium written in? Is this like a C++ memory leak or something? Because it looks so much like one. And we're like, no, it's written in Go. I mean, you can have a memory leak if you keep hold of references and stuff, but you know, Go will get rid of all of that for you. And then I got a delightful Slack message.
Yes, this was a low moment for me. For debugging purposes, we had GoGC turned off. Yeah, to my defense, this was one of my colleagues as well. Yeah, it's not me. But I was the one of us, you know, bridging the communication between us and ISO1. So yeah, I guess key takeaway, yeah, don't turn off.
Don't turn off GoGC. And I think, yeah, that's all we had, really. Thank you.
Very much. Yeah. Time for questions? Yeah.
Questions? Raise your hand if you could, or indicate, raise a leg, anything. I know it was a really good talk, right? And it left you speechless. Okay, we've got one customer right here.
Really good talk. Thank you very much. I have like a really simple question. When you mentioned earlier on about CNI solution, what does CNI stand for?
Container networking interface. So when you deploy Kubernetes, there's a kind of this pluggable set of interfaces you can use. So CNI is just how the networking is provided. There are a bunch of them in the CNCF. So Calico is another CNCF provided one, which I don't know much about. And there are a bunch of third-party ones that, like, outside of a CNCF are also CNIs. It's just what provides the networking for a cluster.
Got it. I'm kind of new to the space, so I appreciate that.
Sure.
Thank you.
Great question. Anybody else? Okay.
No.
You said with the contract issue that it was previously taking 4 hours.
No,
So-
it wasn't taking 4 hours.
So the next cleanup was scheduled in 4 hours.
Yeah. So what happens with this dynamic thing is that every time it could do a contract GC, it will check to see if it's elapsed enough time since the last interval. Because the GC is expensive, right? Like it has to like stop the world and go do a bunch of stuff and faff around at some UPF maps. Which meant, of course, like our solution of making it happen more often did have a CPU usage impact,
Yeah, exactly.
but it was just like considered not as bad as this.
But why would it take such a large interval between?
So I actually had a slide that answered this question, and the answer is I don't know, which is extremely unsatisfying. And the problem is that we only really saw this behavior on GR's cluster at like hundreds of nodes, and like trying to replicate it was just so difficult. My suspicion is it's because of extremely spiky traffic patterns.
They're just going to fill up the contract.
Well, no,
weirdly.
I think that I don't know this. I don't have evidence, but my suspicion is that what's happening is that you had nodes which didn't have very much traffic, or like a low level of traffic, and then they got a workload scheduled onto them. It did a load of traffic that filled up the contract table very quickly, and I don't know how fast the dynamic thing can like
that makes sense. Sure.
reconcile how fast it figures itself out. So the problem was not that like the interval was going up from 4 to 7 hours.
It's that the rate of filling was different to the interval.
Yeah. It was that it couldn't figure that out, I think, was a problem. So we're setting it to 10. We pay the cost of more CPU usage, but it was
That's reasonable.
reasonable.
Okay. Thanks, man.
to this.
Good question. Anyone else? Okay. Thanks very much. Indeed, that was amazing. Thank you, James and Luigi. Let's give them a round of applause.
All right.
Hey everybody, thank you for continuing to share your afternoon with us here. We're going to have a talk now, a 30-minute presentation from Korai, and it's the Kyverno Chronicles, a DevSecOps tale. So I love hearing stories, so excited to hear this from Korai.
Thank you.
Yeah, thank you very much. And at the end, we'll have some Q&A. If you have any questions, please note them down.
Yeah.
Take it away.
Yeah, thank you very much. Welcome everyone. I've been attending Rejekts since Valencia, so this is fourth time, and I had a couple of lightning talks, but this is the first time that I'm doing a longer presentation. So today I'll talk about Kyverno. Who are using it already? Oh, okay. Who is planning to use or never heard of it or tried it? You are definitely in the right room. For the others, so this will be more like an introduction talk. I mean, you're always welcome to join, of course, but just to make set the expectations, so you might also get bored a little bit. So my name is Koray. I work for Kubematic as a consultant. We do consultancy trainings and the other stuff. I'm Turkish, living in Istanbul. I'm CNCF ambassador since the last year, and Cube astronaut. So yeah, I have a bunch of certificates. I am Kubernetes contributor on Kate's infra, also on API Snoop, where we do the conformance testing for Kubernetes distributions. I'm also organizer for KCD Istanbul and DevOps Days Istanbul as of this year. So here are my profiles and stuff. You can, if you want to connect, you're always welcome. So before I will jump to Kyverno stuff, I just want to refresh the knowledge about Kubernetes. So in Kubernetes, we have two main components, the control plane and the worker nodes. And in the control plane, we have controller manager, scheduler, cloud controller manager to create the cloud resources, API server, and the etcd, so the database. And also on the worker side, we have the kube proxy, kubelet, and the runtime where we run our workloads. And using kubectl commands or like the dashboards, like Kubernetes dashboards and other stuff, you can interact with your cluster. The important point here is the API server is the key or the entrance point to the cluster. All the requests goes through API server, and API server is the only component who can write to etcd. So all different components, if they want to change something in the cluster, all the traffic goes through the API server. So how does the API server take care of the access control stuff? When you run a kubectl command or any pod running inside the cluster, want to make some changes or want to get some information out of it, there are 3 steps. The first one is the authentication, so you must be a valid user in the system. And then the authorization, you must have the permissions to do that action, reading the pods, creating a new pod, deleting a deployment, whatever that is. And then the third step is the admission controls. I will come to that admission control part, and if they are all successful, then the data is written on etcd, and then the rest is the magic of the Kubernetes is going from the etcd side. So, but to be able to make a change, you have to go through those 3 steps. And for the admission controllers, Kubernetes already provides some compiled-in ones, like default storage class or limit ranger. Yeah, put it twice, but you can say that, yeah, there must be a default storage class in this cluster, or you can put limit ranges per namespaces, etc. And also, the other part is that where you have the puzzle thingy, or you can make different decisions for your cluster, is the dynamic admission controllers. And these are, there are 2 parts or 2 types of those dynamic ones. They can be validating, so you can just check the incoming request. If it is a valid request or not, you can reject it. You can say that no, you cannot create a pod without resource requests or resource limits. You can do such stuff. Or you can mutate the incoming request, saying that, okay, this request do not have resource limits, but there must be some, so I define resource limits for this incoming deployment. You can do such stuff as well with dynamic admission controllers. So, all in all, what is Kyverno then? It's Greek for govern, and you can create policies as Kubernetes resources. So you probably also heard of OPA, where it's another policy engine and gatekeeper. The problem or downside of OPA is that you need to learn another language called Rego. I'm not saying that it's a bad thing, but it's something that you need to invest time, or your team needs to invest time on it. But with Kyverno, you continue with all YAML or Kubernetes native stuff. Again, not saying that YAML is great, but it's in our daily life, so it's there already, so you don't need to spend much more time with it. Using Kyverno, you can validate and mutate things, mutate requests, incoming requests, and you can also generate or clean up some resources using Kyverno policies, which I will show some examples as well. For example, you can also verify container images for software supply chain security, where you can check the signature of of the resources or SBOMs, etc., etc. You can do that sort of stuff. Kyverno is able to inspect the metadata of the images, so you can define things like, yeah, I don't want to run a container which was built older than 6 months ago. So you always want to have new images to be running in your system. You can synchronize configurations across namespaces. Whenever there is a new namespace, you can create some stuff on that namespace. And it also comes with a CLI tool where you can test the policies in advance. For example, in your pipeline, whenever there will be a new deployment, you can first check if it is valid request for your policies in advance, and then maybe stop the pipeline there, asking for people to change that deployment or some other resources in this new request. So we deployed Kyverno, we created some policies, we are all secure. That's great. And if we check the high-level architecture of things a little bit again with Kyverno, or where does it fit in the picture? So whenever there is a new request coming into the API server, there is a HTTP handler. It does the, again, authorization and authentication and authorization stuff. And then it first runs the mutating admission controls. So if you want to change things, again, if you want to deploy some default values for resource requests or limits, or if you want to add some new labels to the incoming deployments, incoming, I don't know, whatever you want to create there, or annotate some stuff, you can do the mutation. Then with the mutating admission, the admission review and the whole Kyverno part with the webhook and the engine, everything runs. So in the end, the API server calls a webhook, another process. The magic runs in the Kyverno engine and responds back a success or fail to API server. If it is successful, then there will be a schema validation where if your YAML, everything is correct or not, after mutating especially. And then the validating admission webhook is called again. So this time you are checking if the incoming request is valid according to your policies or not. Again, you can say that, yeah, you cannot run this image, you cannot deploy a container from this repository, you cannot deploy an old image, or you cannot deploy an image with the latest tag. You can define those kind of policies, and the validation webhook will check for those. Again, after the Kyverno magic, things are committed to etcd, and then this time the Kubernetes magic is running. The deployments are created. The controller manages take care of the whole stuff. Kubernetes runs the container, etc. There are some background processes, like policy reports and everything, where they run within the system all the time and create some reports like, hey, you have this policy and this deployment is not, it's against this policy, so you need to take care of some action. But those background policies do not, like for example, they do not delete your deployment, or they do not change your deployment. They only report saying that this is against the policy, you need to take some sort of action. Another thing is that, as you can imagine from this whole flow, Kyverno, or all those webhooks are triggered when there is a new request. So if you have already deployed some stuff on the cluster, they will continue running. They might be reported by those background scan reports and the others, but Kyverno will not take a corrective action to change those. And yeah, as long as there's a new request, things will be checked and then will be either rejected or mutated or whatever action you defined in your policy. So the problem with the webhooks is that, especially in this case, if the webhook is down, effectively your API server is down. If it cannot get an answer from the Kyverno webhook, then the whole thing will fail. Like it will just time out, and your kubectl command will fail. It won't be able to create the deployment or whatever resource you are trying to create. So first of all, it's quite important to have a high available, like multi-pod or multi-replica deployment for Kyverno. It's really in a critical path, I would say. Yeah, I mean, we had a customer where, yeah, they had issues with the Kyverno, and then they had quite some downtime. I mean, of course, the downtime is on the API server side, so the workloads are still going. I mean, I don't know if you, yeah, the downtime definition for Kubernetes is a little bit different, but at least it's downtime on the control plane side. Of course, the workloads will continue running. There is also a configuration for that. It's called failure policy. You can say that, yeah, okay, if you cannot get an answer, you can just allow the request. That's also possible. So if Kyverno is down, API server will continue running, but then your policies will not be applied. So if you have mutating policies, then at some point after the Kyverno is up again, you need to manually fix those mutations, or also for the validations, they won't be working. So yeah, the values are ignore and fail, and I think the default is the fail, so be careful about that part. I would like to show some policies, some examples. For example, I think these are basic. These are the things that we discuss in like every security training, or any, if you check the security blogs, it will say that, hey, you should not allow privileged containers. Of course, there are some exceptions for that, especially some daemon sets need those things within your cluster, but for the user workloads, you should not allow it. And you can say that, again, in a YAML format, if containers or init containers or ephemeral containers, if they have the security context privilege defined, they have to be false. This one is, so again, validate, do you see this one? Yeah, so this is a validation admission, and also the action is audit. So you can have two types of actions. You can audit those. You can just write them in a log, and the request will be accepted as well. So in this example, it will create the deployment or the pod, but it will audit it. The validation failure action could also be enforced, and then in this case, it will just give this message saying that privilege mode is disallowed. You cannot define those fields as true. Or yeah, you need to set it to false. So that was one thing, and these are also cluster policies. So this is valid for the whole cluster. You can also create policies which are namespaced in this case. So you can say that in this namespace I don't allow this, in that namespace I don't allow that, etc. So you can create different policies per namespace too. Yeah, I already said this, blocks tail images, so it can check the image metadata and saying that images that are built more than 6 months ago, they are not allowed. But again, today you deploy it, after 6-7 months, if you haven't updated it, it will continue running, and Kyverno will report it at some point saying that, hey, there's an image running in the cluster, it's older than 6 months, but it will continue running. Kyverno will not take any action to change it, but it will report to you. That's also something you need to consider. This is something I prepared for a customer, but we did not apply it for different reasons. But you can also make, as I said, you can do mutations, and you can also do some sort of calculations or arithmetic things there. So this one sets the CPU limits to less than 10%, to make them, how do you say, reduce 10%. So it gets them, divides them by 10, and multiplies by 9. So if you requested 100 millicores, this will mutate it to 90 millicores and apply it this way. So you can also do that sort of different arithmetic calculations as well, if you need to. I think other than validation and mutation, the generation part is also important. In this one, for example, whenever there will be a new namespace created, it will create a default deny rule for that namespace. So you can make sure that whoever in the cluster creates a new namespace, they will have this or some other network policies in place already. So yeah, I think that's also quite important for, that sort of actions are quite important for the admins or SREs or people who are administrating that cluster. Yeah, another one is so this is another network policy to allow DNS. So the first one just puts the deny all, and then the other one is allows the DNS to the kube system namespace. So with these two cluster policies, whenever there's a new namespace, those will be created by default. You don't need to take any other action. And another one, this is also like a best practices thingy, right? You should not run any deployment or any workload in the default namespace. That's what's said on the book. So, but you cannot make sure that people follow it, but you can force them to saying that, hey, default namespace is not allowed, you need to create your namespace, and then blah, blah, blah. Kyverno website has a lot of examples as policies. You can check them out. I think it's a nice place, and people just put it there as open source. There are many, many examples there. There is another thing called validating admission policy, which is, I think, alpha was on 1.26 Kubernetes, and since 1.30 it's stable. So you can also define those. This is like native Kubernetes, so you don't have to have anything else with the validating admission policy, but it's only for validation. So it doesn't do mutating, it doesn't do generate. But it's also there, so if you only want to do that sort of thing, you even don't need to install Kubernetes, but continue with the native. You don't need to deploy Kyverno. You can continue with the Kubernetes objects. So, demo time. I will use Killer Coda. The things are there, and then you can also use it as well. I think I didn't need to do this, so 1 second. In here, yes, that's great. So, the installation, you can do it from the install YAML just directly, but this will have one replica thingy. But if you want to have a high available deployment, yeah, you can do it with Helm with multiple replicas, or you can just increase the number of replicas for your installation. So this will create bunch of custom resource definitions, service accounts, and everything, the roles. Yeah. Let's check the CRDs. So you will have admission reports, background scan reports, cleanup policies, and cluster policies. As I said, cluster policies are for the whole cluster, but you can also have namespaced policies too. Let's check the Kyverno namespace. Is it visible, or should I increase the size, font size? Okay. This, I think, better. No, this one. Pods. So we have the admission controller, background controller, cleanup controller, and the reports controller. And let's wait for the pods to up and running. Okay, cool. Yeah, all of them are running now. So I have a private Docker hub to install Nginx, which has latest tag 125.1, and that's it so far. I need to export Docker user. I've already defined Docker path. So I want to create a secret called Recruitment. So because I want to deploy some images from that private repo, and I also want to use this repo for some other purposes. Then, so for the image metadata to be able to check it, Kyverno itself will need to access to the repo. So the Recruitment is for the kubelet to be able to download the image, but if you want to check for the image metadata, then Kyverno will need to access to this repo, and then you also need to provide this image pool secret to it as well, to its definition. So I will also do that. I just patched it to say that, hey, this is my registry credentials. Use those if you want to check the image, which will, yeah, I will use it in a second. And I also don't have, I think I won't have time for questions, but I'll be around. And that's always. Do you have any questions? Meanwhile? No? Yeah. Yeah.
Oh, we have a question here.
Thanks very much. We've just started using this the last couple of weeks, and what advice would you have about kind of policy sprawl, where the answer to everything seems to be a Kyverno policy?
Policy, sorry?
Policy sprawl, kind of where the answer to every problem seems to be a policy. It does seem to be the case, to be fair.
Yeah, I mean, I think the policies and I'm a consultant, so I'll give you the default answer. It depends for the organization, for what you want to do or how you want to do it. So again, there are some how do you say, best implementations, best the things that you need to do, and there are many policies around those. But what you want to apply there, or how you want to apply those, is I think totally depends on what you want to try. And also, I think what you define on your test environment and production environment would be different. So that's also another thing to consider. But I don't have a specific answer to for that. I'm sorry. Yeah. Yeah. Back to the demo. So I have a policy to sync secrets. So I want to actually sync this registry credential to every namespace whenever I create it. So that means whenever someone wants to deploy something to their namespace, I mean, they create a new namespace, they want to deploy this Nginx image or an image from the private repo, they will have the registry credentials in the cluster already. They won't need to define it on their own. That's the idea, or that's what we want to try. So all I'm saying is that whenever there's a new namespace, generate the secret called regcred and synchronize it from the Kyverno namespace called regcred secret. So it will just copy it whenever there will be a new namespace, or that's the whole idea. Let's create it, and if I check the cluster policy, it's there. So I'm just creating a dev namespace here, and if I check the secrets, the regcred is already created there. And if I also check the annotation, the labels, you will see that this was created by Kyverno itself. So I did not do it. So this is a very handful thing, especially for dev environments or for your customers. They will not need to deal with any secrets or something. The next is that, yeah, I want to deploy this. I'm using the latest image now in that private repo. So this is my private repo. Let's create this. It's created, and if I check the dev namespace, sorry, I need to show this one again. So I didn't use any secrets like image pool secrets thingy, and if I check the pod now, it's pulled back off because it cannot access to my private repo. So I have another one saying that whenever there is a pod created, patch it, and saying that, and if the image is this, like in my private repository, add this pool secrets thingy to the deployment. Let's apply this. Let's apply this. And I will replace it. I'm replacing it because it won't change anything on the running thing. I need to create this request from scratch. And if I check the pods now, it's running, and you will see that it added the regcred here. So again, you create the register credentials automated. You add the image pool secret automated, so your customers or clients will not. They don't need to know anything about it. You automated this already on your cluster. And I don't have a time, but I really need to show this. I'm so sorry. So let's export a tag, and I want to build a new Nginx image with this tag. And so you are able to use call sign with Kyverno as well. That's also a nice feature, especially for software supply chain. So I will not go into details how call sign works, etc. But yeah, I just create a new key pair for call sign, and with this key pair, I'm signing my new image. Yes, yes. So what happens here is that, so it pushed the signature to here, and if I check the tags again in my private repo, so I created this tag. It was created like a minute ago, and also created the signature there. So I have the signature as well. So I have a new policy called verify images, and I'm saying that using this call sign key pair, which I just created, verify those images. Make sure that those are signed with this key. Otherwise, do not deploy them. That's the whole idea. So if I delete and recreate this deployment, it was still the latest image. It's still the latest image. I didn't change the deployment. And if create it, really. No, that shouldn't have happened. Pods, dev. Because I didn't apply the policy, right? yeah, without the policy, it won't work, of course. Delete. Create again. Yeah, it says that, yeah, this is not signed. This is the latest image. It doesn't have a signature. That is true. Now I'm changing patching the deployment. Now I will use this, my new tag, and let's create this. And now it's created. And if you check the output, you will see that now it's using this new image, and yeah, there is also a notation saying that, yeah, Kyverno verified that image. That's also demo. I did fast, but yeah, I think you got the the idea. I think we don't have time for questions, but I'll be around all the time. I mean, today, so just you can ask anything. And there are a lot of resources around Kyverno. I think it's a good practice to use it. Yeah, thank you very much.
Yep. You all can hear me fine, right? Awesome. Thanks everybody. Thanks for showing up at our talk. So I am supposed to give this talk with my co-speaker Priyanka Sagu, but she just arrived in London today, so she was not able to make it. So I'll be giving this talk entirely by myself. And yeah, let's get right into it. So this talk is about common expression language. So common expression language, or CEL as we call it, is something that is up and coming in Kubernetes. And yeah, this talk is about how CEL is shaping the future of Kubernetes, and how we are able to extend Kubernetes with CEL. So who are we? So my name is Sridhar Venkatesh. I work as a senior software engineer at DigitalOcean. Priyanka Sagu, my co-speaker, she works at SUSE as a Kubernetes integration engineer. And yeah, this talk is based upon our work from the past like 8 or 10 months. So before I start with the talk, I wanted to get some things out of the way. So I'll be using some acronyms and some specific terms which I wanted to clear what they were. So CEL obviously stands for Common Expression Language. When I say CEL upstream, what I mean is the Google CEL Go package, which is used to integrate Common Expression Language inside Kubernetes. CRD obviously stands for Customer Source Definitions, and KEPs are Kubernetes Enhancements Proposals, which are how new features added to Kubernetes are tracked and added to the release. So the agenda of this talk, we will look at what CEL is, how CEL is used in Kubernetes today, and how CEL itself works, like how the expressions are compiled and parsed and all of that. We'll look at how CEL evolved in Kubernetes over the last 10 releases, and towards the end we'll look at what we were working on with CEL, which is adding CEL to custom resource definitions, additional printer columns. So the major focus of this talk would be the last 2 points, where we talk about how CEL is being used in Kubernetes today and what we are trying to do with it. So what is CEL? So all of these statements I've taken from the Google CEL Go repositories README file. CEL stands for Common Expression Language, and it is developed by Google. And it is a lightweight scripting language which you can use to evaluate expressions within your Go programs. Well, not just Go programs, like any program, as long as the language support is there. So this is how a CEL expression looks like. If you have a variable called name, you can check if that string starts with a particular letter, or if you have a list of strings, you can check if all of the elements in that particular array starts with a particular character, or if they're under a particular character limit, and so on. You can find, so in all of these slides, I have links at the bottom of the slide. You can see more examples and find more information related to each slide. I'll share the slide deck at the end. So before I go into how CEL is used in Kubernetes today, I wanted to give a an example of how we write CEL expressions in Kubernetes. So these are some things that we can do with CEL in Kubernetes today. Like you can work with the information in your spec or status of your workload and so on. So let's look at a few metrics to see how, a few metrics to show how CEL is quickly becoming relevant in Kubernetes today. These are the list of Kubernetes enhancements proposals which deal with CEL. So there are about 11 features which are actively adding CEL functionality to Kubernetes. And yeah, when I search for CEL in the Kubernetes code base issues, I can see 6 pages of issues, and the latest one was created very recently. So CEL is area where active development is happening in Kubernetes. And we also have a API Machinery CEL dev channel in the Kubernetes Slack workspace if you're interested in reading the discussions that are happening about both using and integrating CEL into Kubernetes. And again, one more example I wanted to show to show how CEL is used in Kubernetes today. This was a CVE that was reported recently, and one of the solutions to mitigate this vulnerability was to use a validating admission policy, which in turn uses CEL to like in this particular example, it uses cell to restrict pods. So this is a vulnerability with the Git repo volume, so you can make sure that the pods created are secure using cell. So now let's look at how cell works, because I've been talking about cell for quite some time now and I've not really gone into the details. So this is at a very high level how cell expression evaluation works. We have a cell environment where we can define all of our variables, and we compile our expression against this environment. And at this stage, we'll type check all the variables and check if the expression itself is like valid. And if that compilation is successful, we get an abstract syntax tree, which we can convert to an executable program, and we can evaluate that program against our inputs. So we'll take the example that we had in the first slide, and we'll walk through all of the steps with the necessary code. So I'll be writing a Go program, which will take a cell expression and compile it, and then evaluate, it will evaluate that expression against a particular input. So the first thing I do is I import the cell Go package. I hope the font size is legible. So once we have the cell Go package, we create a new cell environment, which we can do with cell.newEnv, and I pass a variable here, which is called name. And the variable has a type of string type. So name essentially takes strings. So once we have the cell environment, we compile the cell expression that we had, which was, we were checking, the expression was checking whether name starts with the character A, and we pass that expression inside env.compile, and we compile that cell expression to get an AST. So at this point, like env.compile is just syntactical sugar for env.parse and env.check, which are two different methods which are available. So env.parse will check if the cell expression is if the syntax is correct, and env.check would type check the expression against the variables that we've defined in the environment. So if we are trying to do starts with on an integer input, then it would fail at that stage. So env.compile just does both of those and gives us the errors if there are any. And once we have the AST, we can convert the AST into a program, which is what we do with env.program. And once we have the program, we can call program.eval, and we pass the list of our inputs. So here I pass the name as Alice, and when I do program.eval with this particular input, since our expression checks whether the name starts with the character A, it returns true. Yeah, that's how cell works. But now let's see how cell is used in Kubernetes. So cell was first introduced to Kubernetes 10 releases back. We are now in the 133 release cycle. Cell was first introduced in the 123 release cycle as a way to write custom validations for custom resource definitions. So this is the release blog post for the 123 release where the feature was introduced. And I will show how the CRD validation itself works, but this is we are quickly going through the pull requests that added cell support. So this is the first PR in Kubernetes which had anything to do with cell, and what they've done here is they've copied over some logic, some models, and environment from the cell Go package in Google. So they added cell in a wired off state. So all the necessary vendor files were there in Kubernetes, but it was not being used anywhere. So this is the PR that does that. This was created in I think this was merged in November 2021. And the next two PRs that we have adds, wires up cell, the logic that we added in the previous PR with CRDs. So as part of this PR, as you can see, the commits that have been highlighted, it adds, this particular commits wires up the cell compilation logic with CRD schema. So what happens here is essentially everything that we saw with the earlier example, where we take the cell expression, compile it against an environment, and evaluate our input on that cell program. Essentially that happens here, but the input is the Kubernetes structural schema of the CRD, and the validation rule checks where, we can write custom validation rules. We'll go into that. And that is what is being done in the highlighted commit here, and in the further commits, what is happening is this is wired up with the validation logic of CRD. So along with everything else, we will execute our cell program as well. So this is how that particular feature looks when you actually use it. So this is an example CRD, and at any block of the schema, the OpenAPI v3 schema, you can define an X Kubernetes validation field, which takes a rule and a message. So the rule here is a cell expression, and here the rule checks if self.replicas is in between like min replicas and max replicas. So if this validation fails, we can show an error message, which is what is defined in the message field. It says replicas should be in the range of min replicas to max replicas. So essentially that validation logic is like encapsulated in this particular cell expression. So before the advent of cell, if we were to write custom validation logic such as this, you would have to like it is not as straightforward. You might have to like deploy your own webhook server and so on. So cell makes it easy and adds this extend, like it makes it easier to extend the Kubernetes API server, and it adds like native support for that in the API server itself. So once this feature was done, yeah, so this was alpha in 123, it graduated to beta in 125, and it graduated to stable or generally available stage in 129. So if you're using Kubernetes today, and if you're using a version above 129, cell validation for custom resource definitions are enabled by default. And once this was done, in the first PR that we saw, the cell logic that was added to Kubernetes was specific to custom resource definitions, but later this was moved to its own package, and now cell can be used anywhere in Kubernetes, and all the caps that we saw in the earlier slide adds cell support to different areas of Kubernetes. Like today, dynamic resource allocation is also using cell in some manner. So I have like two specific examples of how cell is used in different parts of Kubernetes. So we have, as part of admission control, we used to have validating admission webhooks and mutating admission webhooks. So what they did is, if you want to write custom validation rules for your pods, let's say you would have to write the validation logic in a webhook server, and you'll have to deploy and maintain that in your cluster. But you can now do it with validating admission policy instead of validating admission webhook. So what validating admission policy does is you can like define expressions using cell, and this validation would be enforced across your workloads. So in this particular example, we are creating a new rule to we are creating a new rule to validate whether all our deployments have at least 5 replicas. And if we try to create a deployment without with a replica count less than 5, this validating admission policy would fail, and we would show an error message. So similarly, we also have mutating admission policy. So this particular example uses cell expression to check if a pod that we are applying to the cluster has an init container for a service mesh, and if it is not present, it applies this patch to add that init container. So cell is being used to identify which all containers have that init container or not. So that is an overview of how cell is used in Kubernetes today. So now I'm going to talk about what we have been working on with cell. So we've been trying to add support for cell in a new area of CRDs called additional printer columns. So I'll explain what additional printer columns are and what the what difficulties we are facing with it today and how cell can improve it. So essentially, additional printer columns lets you define what all columns should be printed in the output when you do kubectl get custom resource. So this is how it looks. So if you have a custom resource definition, and when you do kubectl get my CRD my resource, this is what you see. So these different columns are defined with cell. So if you have a CRD for let's say Argo CD app sets, when you do kubectl get upsets, you would see a list of columns, and they are all defined in the CRD definition. So this works today for querying, but if we want to work with more complex data, and if you want to do like conditional operations on this data, JSON path does not let us do that. So there have been a lot of issues which have been created, like where people face this issue, and people wanted to use JSON path to write complex expressions, but they were not able to. Like JSON path does not let you work with arrays, and yeah, in this example, like we cannot show duration. So if we have like a creation timestamp, and if we want to get the duration from that timestamp, like JSON path is not able to do that. And yeah, if we have like a list of items, we are not able to show all of them. So let's say we have a list of IP addresses. JSON path is only able to show the first item in that list. So those are all like limitations of using JSON path. And yeah, these are some examples. There are a lot more issues. This is an entire list of all the issues where people have like people wanted more out of JSON path, but they were not able to use JSON path to fulfill their requirements. So this has been like an issue for a long time, and people have tried to solve this in the past. People have tried adding like support for complex JSON path which can work with arrays and so on, but because of several reasons, none of these were like merged. So in this particular comment by Nikita was one of the contributors who worked with CRDs a lot. She mentions that it is not a safe approach to extend JSON path in this way to let people do whatever they want. So this was the case like around, like this was in 2018, so that is like, what, 8, no, not 8, like many years ago now. Yeah, I can't do math right now. Yeah, so this was the case back in 2018, but now that we have Cell, we can make use of Cell to like do all of this and more. So we started a new Kubernetes enhancements proposal called Cell for CRD additional printer columns, and what we propose is adding a new expression field along with JSON path in such a way that you can define additional printer columns using either JSON path or expression, which is, in this case is a Cell expression. And the API server would compile the Cell expression and execute this Cell expression against all the custom resources when you query for them. So this is how the kubectl explain output looks once we added that field. I don't think this font size is legible, but what we wanted to show here is that the CRD additional printer column definition now has an expression field along with JSON path. And yeah, I have a quick demo to show you. So this is a simple CRD called shirt. Let me know if you are not able to read this. Yeah, this is a simple CRD called shirt, and shirt has 2 items in its spec. It has a string property called color and another array of integers called sizes, and these are the additional printer columns that I've defined. So earlier, if we wanted to show the list of sizes, which is an integer array, that was not possible with JSON path. So if I try to show spec, so here spec.color is a string, and we are able to display that, like we are able to add an additional printer column for spec.color using JSON path. But if I want to show spec.sizes as a JSON path query, that does not work. But we have a string for the color. Since this is just querying the data and displaying it, JSON path works fine. But if I want to write a more complex expression, say I want to check if this custom resource has a value for spec.sizes, and if that is present, then I want to show whatever that value is, or if it is not present, or if it is not set for a particular CRD, sorry, a particular custom resource, we want to show an empty array. So this sort of conditional expression can now be like written with additional printer columns, and this is a cell expression, and this would be compiled by the API server. So I have a cluster running where I have applied the CRD. So before I query it, I will also show you what the custom resources I've applied are. So I have 3 shirt resources. The first one is a color of red and a sizes array of 2, 3, and 4, which is an array of integers. The second one has a color of yellow, and it has an array of 1, 2, and 3. In the third shirt, only the color is set. The sizes array is not set since it is an optional value. So I've applied both the CRD and the custom resource. So all these 3 shirts are now created, and now if I query for shirt, if I do kubectl get shirt, I can see that it prints all of these columns that I've defined with the additional printer columns. And here what happens is the first column just prints the color of the shirt, which is querying it using JSON path. In the second column, we are showing the available sizes, and now it is printing an array. And in the third case, since we did not set any value for sizes, it prints the empty array based on our cell expression. And there is a third column which I did not talk about in the CRD definition. So here also we are doing a conditional expression where we check if the sizes is present, and based on that we show true or false. So here, since the third custom resource has an empty array, it shows false. So I have another example that I wanted to show you. So this cell expression checks if spec.color is blue, and if it is blue, then it prints true, or it prints false if the color of the shirt is not blue. So I added this new column called isColorBlue, and now if I apply the custom resource definition, and now if I query for the shirt again, I have a 4th column which basically executes the expression that we just defined, and in the third shirt, since it is blue, it says true, but all the other ones are false. I think I have like a bit more time, so I'll also try to show you how this does not work. So if I want to print spec.sizes with JSON path, I've not tried this before, so I'm going out of my routine here. So I'll try to apply this CRD now, and if I try to get shirt, yeah, this still comes up, but see in this case how it has an empty value. We are trying to query the multiple like the field that has multiple values using JSON path. In this case, it does not print any value. So if we want to show an empty value, we can use cell to do that, and like for sure, JSON path does not let you like write complex cell expressions. So this is like a quick demo of what is possible with cell. Yeah. Right. Right.
Can you repeat his question so that the stream can pick it up?
Yeah.
Yeah, I was just curious about the use of string types across the board here. Is there a use case for actually doing something different there and extending it to even arrays or list of integers or something along, so you can do something more sensible with that data?
Yeah. So here, when we say type string, in the case of JSON path expressions, I think that there are a list of types which are defined, which you can like use here for additional printer columns. And in the case of JSON path, most of it is just querying data from the CRD spec, so most of them are strings. But in the case of cell expression, here when we say string, the cell expression itself has to like evaluate to a value that is a string type. So if we should be able to extend it so that we can write a cell expression that would. So here what happens is even though we are evaluating to a Boolean type, that value is converted to a string, so that it can be printed in the, like there is a table converter.go file which would convert those values so that it can print it in this format. So there is like like I'm not sure if that is how it works, like whether the even if the cell expression does not evaluate to a string, it is converted to a string, like that value is converted to a string at the end. But if we have, like today we have like different decal types for cell. I don't have a slide for that, but we have like declared types for CRDs, like the CRD fields which are used in cell. Like they've added support for that in cell. So you have types like IP address, CIDR block, and semver, and so on, which are used in different parts of Kubernetes. Like DRA, for example, uses semver and IP addresses. So you can essentially make a cell expression evaluate to a IP type, and then you can like work with them. But here, I don't think it really matters because ultimately it's just printing the value, so everything gets converted to a string at the end.
Thank you.
Thank you. Yeah, so that is a quick demo of how it works. Like all the examples that I've used here are like fairly simple, but as I said, we have a lot more types and a lot more things that we can do. Like just having the ability to run any expression that you want lets you do a lot of things. And yeah, this is like all the issues that we saw earlier would be resolved now that we have cell. So yeah, this was a quick example in case the demo didn't work. But here are a list of resources where you can learn more about cell. Google has a good code lab where you can walk through the initial example that we did, where we'll take a simple hello world cell expression and then we'll write Go code to compile it and evaluate it against the input and so on. There is also an issue called a wish list of cell libraries. This is an issue in the Kubernetes repository where people talk about how they're using cell and what they want in cell that is not already there in Kubernetes today. So if you are interested in contributing to Kubernetes in this particular area, this is something that you'd be interested in. Yeah, then the Slack channel and everything. And yeah, I also have a blog. So this is kind of like a shameless plug. I have a blog where I write about how I like develop like features for Kubernetes, like how I run Kubernetes locally and so on. So if you're interested in that sort of thing, you can take a look. And yeah, this QR code gives you this slide deck, and you can like contact both me and Priyanka. So we have been working on like whatever demo that we showed here today. Priyanka and I have been working on like all the code that goes behind doing the cell compilation for CRDs. Yeah, we've been working on that for the past 8 or 10 months now. And yeah, if you're interested to talk to us, you can message us on Slack, or we'll be there at KubeCon also, so you can like, come talk to us. Yeah, that's the end of my slide.
Any questions? Yeah. Any questions? All right. Well, thank you. We'll break for about 5 minutes, and then we'll have our another talk at about 40 minutes after the hour.
Thanks, folks.
Okay, thank you. Welcome for these sessions. So here with the big title you have here, the goal of the presentation is to show you how we can use OCR registry with something else as images in a secure way. So I will present you first a short introduction, then present how the container initiative specifications are, how to store images and artifacts, and how to attach artifacts into OCR registry. Then I will show you some use cases, how to store OCI registry artifacts, so see OCR registry as a storage, with some personas, and then I will conclude with some takeaways. So first of all, introduce myself. I'm Stefan Estegracias. I'm a Cloud Native Innovation Lead at ITQ, a consulting company that delivers multi-cloud solutions with advanced infrastructure and modern digital workspaces. For the community, I'm a CNCF ambassador and co-organizer of Cloud Native Luxembourg meetups. If you want to contact me, you can use this Cestegra handle on social networks or scan this code. So, first, OCI specification. So OCI means Open Container Initiative. This is a Linux Foundation project that defines 3 specifications. The first one, runtime specification, that defines how the container image runs on the host. Image specification that defines how an image is structured. And then distribution is specification define how to store and distribute your images along your platforms. Today, we will have a look on both image and distribution. First of all, distributions. So you need a registry. So registry basically is a service that defines HTTP API endpoint to push, pull images or artifacts from to the OCI registry and get some metadata. You will see just after this slide. So as a usual URL here, you have multiple parts on this URL. First, the registry, that is the host name where the registry is serving the repository, is the second part of the URL. And the last part is the reference. The reference can be a tag, that is a human-readable information, or a digest, that is the immutable information about the content. You can use both in the URL, but in that case, pay attention, only the digest is taken into account. So this information is only for human and immutability, so take care. I will have a look now in the next slides how the image is structured by defining with every element of an image. So first, tags. You can retrieve all the tags from a specific repository using Scopeo list tag, for instance, giving them as a JSON result the repository name and the tags. And the tags basically is a pointer to a manifest, and a manifest is a JSON metadata that defines the content it points to as well. So let's have a look of a manifest. You can get the manifest from any content on the registry by using Scopeo inspect, for instance, pointing to a specific reference on the repository. You will get a JSON result with multiple parameters. The most important one is media type, that defines the type of content of the manifest. So here is the image manifest. So whatever content we will store in the registry will be of media type image manifest, even if it's something else. You will see later in the presentation. And then there are 2 parts in the manifest that point the configuration of the image or the artifact that is stored in a blob. So it's a binary, and most of the time is a tarball inside the registry. And every layers that combine together create the container image. Config is a OCI image manifest, config, sorry, and then the layers is a content that is on compressed tarball format. So here is the usual way of using the OCI registry with images. But with the new specification, the OCI specification implements more how to put in the OCI registry whatever content you want. So to do so, I will just introduce something that is commonly used nowadays, is the mchart stored in the OCI registry. To store an mchart into the OCI registry, you can fetch whatever charts from whatever repository you want. So here is Cert Manager, so I download the tarball of Cert Manager here, and to push it to the OCI registry, you can use the mcli with push command to push it to a specific repository. As soon as you get the digest of it, you can install it using the same command you are used to, but replace here the chart pointing to the OCI registry, giving the full registry name, repository name, plus the version in the command line. And if we have a look on the manifest of this content, using Scopeo Inspect, as we did before, you can see it's exactly the same format, pointing to a configuration and layers. In the configuration, you see it's the M-chart configuration. They will point exactly the chart YAML you get, and the layers will be the tarball, exactly the one you pushed in the previous command. So you see here, it's very convenient to use OCI registry to push artifacts, but in the to secure your environment, you have to attach some artifacts around your images and M-chart, for instance, or whatever artifact you want to push on the OCI registry. To do so, we'll use the attached artifacts from the OCI specification. And basically, the attached artifact you use the most is signatures and attestation. So let's assume you have an OCI registry, you would like to push an image or an artifact. So all the process I will explain here will apply to image or artifact, whatever content. Here I will push an image using Podman. So I build the image using Podman build and push the image with Podman push and gather the digest to be used later to sign it, because you have to sign an immutable version of the image. So with the signature, we will attach these signatures to the image to indicate to the registry that these two artifacts are linked together. To do so, we'll use cosign. So cosign will attach the signature we create here with this command, cosign sign. And here I'm use the new specification for cosign by setting an environment variable plus the parameter registry referrer to OCI 11. By default, it will use a well-known tag we'll see later for the attestation that is ending with .sig with the digest of the content is signed. And here you see all the information that cosign sign did. So he pushed, first signed the content, pushed the signatures to the OCI registry, and then attach these signatures to the image. And if you want to see this hierarchy of information, you can use ORAS, that is a command line that manages to pull and push whatever content into the registry, as well as some tools to discover the content inside the registry. And here I see the hierarchy of content. The image on top is a tree-like dump here, and you see the signatures digest here is the same as we get from the previous command line. And now, if we have a look on the manifest of this signature, the manifest of the signature is the same format or whatever artifact. The only things that change is the config media type and the layer media type that link to cosign definition. So here we attach the signature. Now let's attach some attestation. So attestation can be SALSA, provenance, vulnerability scanning, all the package that are present in the image, for instance. To do so, I will use 3v image command line with the format cosign vulnerability and export the software bill of material file, that is a huge JSON file. Use cosign cosign attest command line with the software bill of material JSON file and push it to OCI registry. And then using cosign tree. So here, instead of using the OCI 1.1 specification, it still use the well-known tag specification, here using .att with the prefix as the digest of the image. And here, with cosine tree, you see this relationship between the image and this attestation. So like that, you can push whatever content into the registry and then get the same format for every content with a manifest that's pointing information about config and layers. Config and layers are stored into the registry as blob. Most of the time, config is a JSON file and layers are a tarball. And you see here the relationship between the attestation, signatures, and image are easily retrievable from the OCR registry API using tools like Cosine or ORAS. So now you see how that every content can be set into OCR registry. Let's have a look now, some use cases about how to use OCR registry as a storage with specific personas. So let's introduce some personas here. So Dave is a platform engineer of this session. There is as well some developers. So here Alice is a developer of whatever Kiwi application. This guy, Bobs, is a developer that developed WebAssembly applications named Grapes. And then, because we need AI on every talk, Charlie is a data engineer that is managing AI application. So before that, we need a platform. So Dave, as a platform engineer, needs to bootstrap this platform. So here the goal of the presentation is not to create this platform, so I will go fast in the configuration of this platform. To do this platform, it will use this toolbox, so the OCR specification we already see, Forgero as a Git repository, Arbor as a OCR registry, Sigstore to secure the supply chain, Tecton as well for the supply chain management, Elm for the packaging, KCL Lang to create the Kubernetes manifest by code, and Kyverno to manage the policy engine, and then ORAS to push whatever content into the OCR registry. So it's an opinionated platform by Dev. So here, first of all, you need to install and prepare the OCR registry and upload the required component to the OCR registry. Here, it's a private environment, so you need it to get everything into the private registry. Bootstrap the platform to install the required component. Prepare the Git repository for pipeline runs, and platform definitions. And then bootstrap the GitOps operator. So the GitOps operator, I missed it on the list, is FluxCD. So we'll use FluxCD as a GitOps operator, but instead of using Git as a trust store, we will use OCI registry as a trust store. So the GitOps operator will fetch information from the OCI registry instead of Git reserver. So first of all, we need to install the private registry. So we'll use Dev decide to use Arbor as a private registry, so install Arbor. Then from a secured and trusted source of information, of image and charts, so be sure you select your images and charts from a trusted and secure source, because a public registry is the Far West. Then verify the signatures and verify attestation, such as SALSA attestations, software bill of materials, vulnerability, etc., for all of tools that were in the toolbox. So assume you install everything on the Arbor registry and everything is safe. Then, because we need to validate some policy, here, basically, every content that will be deployed on the platform needs to come from this OCI registry. So we use here Kyverno that basically deploy policy into the registry that are WebAssembly modules that are stored as artifacts into the OCI registry. Then upload the Tecton bundle. So the Tecton bundle will be used by the pipelines for Tecton. And the bundle is basically a list of resources inside the YAML file that is pushed into the registry. The same for the KCL module. So KCL is a programming language that creates configuration for whatever Kubernetes manifest. And the module, so the package to reuse for developing this configuration, can be pushed as well in the OCI registry to distribute the module you developed. So now we have all the basic the core component for the platform. So let's bootstrap the platform and install the required component. So you still have here the registry in smaller part, in smaller view. But here we deploy all the components in the platform, then deploy everything we required for the pipeline and the policy admission controller plus the KCL run that comes from every things we already push on the OCI registry. And then to use this platform, you need to push the code and the configuration on Git. So prepare everything from 4.0 Git server. Here, Dave will develop some Tekton pipeline to create all the CI required to use the platform afterwards. He used Tekton modules for doing so, and he create as well some pipeline runs to trigger the pipeline to run inside the platform. So now that everything is there to run, you need to define the configuration of the platform, so the set of Kubernetes manifest that will be deployed by the GitOps operator that define all the environment that the developer will use later on. So his name platform definition here. So it's basically an OCI repository artifact from Flux to fetch the OCI from the OCI registry all the artifacts you want to use and all the configuration you want to use. The Helm release to deploy Helm charts, and then the customization to deploy whatever Kubernetes configuration like CRDs or basic Kubernetes manifest. And this, to simplify the development, he uses as well KCL Flux module that is stored into the OCI registry as well. And then push as well some pipeline runs that is related to the deployment of these resources. So now we have everything in place. We can bootstrap the GitOps operator. So GitOps operator is here Flux, and we configure Flux to use OCI registry as a trust store. So we need to, because we link 4.0 webhook to Tekton triggers, it triggers the run of the pipeline runs. So the pipeline runs is created in the Kubernetes clusters, run the pipeline that points to the pipeline, no, the pipeline runs that point to the pipeline, that use a Tekton bundle into the OCI registry. And then this run will deploy everything. First, push and sign the platform definition pipeline and pipeline runs that were created by Dave beforehand. And then, how to do so, we can use the Flux push artifact command line using the path containing all the artifact, all the definition you want, and pointing to a specific repository here using the Flux CLI. Then you get a digest of this content, and as every artifact you push on the OCI registry, you can sign it with cosign and verify the signature with cosign tree. Then for the bundle from Tekton, you can use Tekton CLI bundle push using a repository as well, pointing to the bundle that contains all the definition you want to have in this bundle. And as usual, you get a digest and sign it as every artifact on the OCI registry. Now, the GitOps operator is ready to bootstrap. So before that, remember the WebAssembly based policy management Kyverno. He has an admission controller here that is linked to a policy stored in the OCI registry. This policy is telling that don't use any content that comes from something else that the Arbor registry, and verify the signatures of every artifact will be deployed into the platform. And let's assume that the verification is okay. So the GitOps operator will deploy by fetching the content from the OCI registry, all the platform definition, and all the environment that the user will consume later. So now we have the platform, so let's consume the platform. The first consumer of the platform is the platform engineer himself. So Dave can use the platform we create to continue to populate the platform regarding the requirement of the developers, for instance. So we can develop the Kubernetes policy, create the Kubernetes policy and Kubernetes pipelines policy there, push them to the Git repository, and because we have the Git triggered the pipeline run, it will push and sign these to OCI registry. The GitOps operator will pull this information after verification from the mission control. And to do so, we use the Kyverno CLI to push the content as regular repository in the OCI registry. And because it's whatever artifact, you can sign it afterwards. But before, we need as well to deploy the admission controller using Flux. So admission controller is defined with specific CRD, and Flux can push it to the registry to be fetched afterwards by the GitOps operator, using the specific things as well. And as every content, you can sign them from the registry. It can develop as well KCL module. So here is the same process. And here, KCL mode push is being used to push content into the OCI registry. And as usual, there are as well some configuration CRD that need to be deployed in the OCI registry. We use as well Flux push artifacts to do so. And as usual, we sign them with cosine sign. You can as well develop Tecton bundle. In the same way, we push the Tecton bundle into Git repository trig pipeline run. The pipeline run push and sign the content into the OCI registry, and etc. You get the point. Here you use Tecton bundle push to the OCI registry, the bundle. You already see this command line just before, and then sign it as usual. So as a result, here you have multiple content into the OCI registry that are not only images. Now, for the developer point of view, you can use this platform and use OCI registry there. As a usual developer, you already know that you can use it to code and develop your environment, create mchart, etc. And the pipeline that will run there will push and sign the configuration required to deploy this application, then the mchart, etc. And you can use the command you already see at the beginning of the presentation, and then sign them, all of three, the binary, the image, the chart, and the configuration to deploy the application inside the OCI registry, and sign all of three with cosine sign. So at the end of the day, the GitOps operator deploy the content inside the repository as other content, and the application is deployed. So for Bob, that developed the WebAssembly application, is the same process as Alice, but here he used as well WebAssembly modules that are stored in the OCI registry as well, using the WebAssembly package tools, and use the WebAssembly command line to push the content, and then sign the content. And the rest here, for the application itself, is the same process as Alice. For Charlie, she is developing AI application, so she needs to have an AI model that she trained. Then you will push this OCI model to the OCI registry for this application to use this AI model inside the Kubernetes cluster. For this, she will use Horace to push the model into the OCI registry, and use Horace library to use this model from the application running inside the Kubernetes cluster. And as usual, we'll use cosine to set the bill of material for AI model. Nowadays, AI have some issue with bias, etc. So to have an attestation that content the document they use, the configuration, etc., you can set it to create an AI bill of material and attach it with attest, as we see before in at the beginning of the presentation. And as usual, you can see with cosine tree the relationship. So then they deploy the application as Alice and Bob did, and the application will use the model from the OCI registry. So you see, content of OCI registry are not just images or charts, but can be whatever you need for your applications, and everything can be signed, and we can add as well attestation to prove the provenance, the vulnerability, or whatever information you need to put on attestation. So as a conclusion, you will see, is my opinion, so more and more the OCI registry will be used for something else than just images. And I see this as well in the the common features for the OCI registry clients. First, Podman will implement in the next version the possibility to mount whatever OCI artifact as a volume. And Kubernetes version 133, the next one that will pop up, will as well a beta version do the same as a read-only image coming from the OCI registry to mount as a read-only volume on the pod. For instance, the Cloud Native PG team will manage the Postgres extension by using this a specific OCI artifact per extension instead of compiling them into the core images. It's exactly what they do for now, and so it's complex to do custom images for Postgres. With this solution, it will be easier to get multiple extensions coming from multiple OCI artifacts and mount them as a read-only inside the pod. So you see here, OCI registry can be used as a secured storage, popping up whatever content you need. So here it was just a demonstration of some tools that already leverage OCI registry as a storage, and you can secure them by using the attach artifacts features to sign and add attestation into whatever artifact you put on the OCI registry. And because you get this signature in the platform, you can run a policy engine that has here this Kyverno that use policy that are stored in the OCI registry and verify the signatures before deploying it to the platform. Thank you very much for your attention. If you have any question, feel free to ask now.
Are there any questions?
It was quite intense for last part of the afternoon.
We're all experts now.
Yeah.
All right. Well, thank you.
Thank you again. And if you want to contact me, feel free to scan this code, or we can meet as well afterwards in the room. Or we'll be at KubeCon as well, so don't hesitate to contact me.
We'll have our next talk in about 5 minutes after a short little break for everybody to shuffle around, and we'll go from there.
right, hey everybody, I'm Mark. I'm a product manager at Red Hat, although for the purposes here, I'm a member of the Podman community. Along with me, I have
Stéphane Lemer. I'm also product manager working on a Podman desktop at Red Hat, but also on various developer tools. So, as you know, Podman is an open source tool for working with containers. Just as we see in this beautiful illustration with Seals, in addition to that, it's also a tool that allows you to work with pods, just like the pods that you have in Kubernetes. But it also appears that a group of Seals is called a pod, so hence the name for Podman, for Pod Manager, and all the cute graphics that you can see all around the project. Those little seals, they are very happy to be here today. They love Kubernetes, of course, and very happy to be here at Rejekts. So thank you for having us.
By the way, I want to say we actually got originally rejected from Rejekts, which is pretty incredible. So I think we're very special. There's look, a lot of people would think of Podman, and I think correctly, right, as basically a Docker clone, and it is that, right? It is that. It is an API and CLI compatible container engine, but it has a different design philosophy, which is summed up in the mission statement here, and as well, actually, we can just go straight on to the next one. So looking back from history, it's been about 8 years since Podman started. Cryo actually came first, and Podman was forked from Cryo into a project called Kpod. Eventually, proper Podman came out and gained a REST API, as well as Compose support, which we'll dig into a little bit. And what's interesting here, since we're at KubeCon, is the added support that came in Podman 4 for the Kubernetes API. So without any cluster around whatsoever, kind or nothing, Podman itself supports the kubepod spec, containers, daemon sets, deployments, persistent volume claims, config maps, and jobs. And while some may feel that container engines are kind of a done thing, we beg to differ. And the last couple of years of Podman development, I think, has shown that. One of my favorite features of the last couple of years is Quadless, which is this tight systemd integration. I assume everybody here loves systemd. And other key features we're going to look at a little bit are artifact support, Z-standard chunked, and ComposeFS. Oops. Just some, the usual vanity stats. We've had a lot of contributors over the years. We have had maintainers outside of Red Hat, and we're looking forward to more as part of the CNCF. I update this slide whenever I deliver it because it seems like the star count keeps climbing. I think we got a nice boost from joining the CNCF sandbox.
Thank you, Mark. So for Podman Desktop, Podman Desktop provides an intuitive and user-friendly interface on top of Podman with a lot of developer flows to help working with containers as well as working with Kubernetes. So it simplifies the container management. It will streamline a couple of workflows, but one which is important, and I will show that in the demo, but it's really the transition from local to production. So the tool itself runs on Mac, Windows, and Linux, and one of the primary goals is to get you up to speed and install and configure and set up to work with containers. So it will manage your container engine, it will keep it up to date, and so on and so forth. It will provide UI for containers, pods, and it will have compatibility with other engines as well. It's enterprise ready, so you can use it behind your VPN with your own proxy configuration. You can connect to any registries you want. And it will also allow you to connect to and bridge to remote Kubernetes environment. But really, our mission is really to focus on the application developers to help them going from the application to containers and then to pods and then to Kubernetes and making this smoother and easy to adopt. The project starts in 3 years ago, actually. And again, while I mentioned that we've been building it on top of the Podman capabilities, it's also been designed by abstracting away the container engine and to support multiple providers. That's very important because this is how the openness reflects in the project commitments for the developer choice, for enabling the users to work with the preferred tool that they have. In terms of status, since 3 years, we've been reaching more than 2 million downloads in total. And we have more than 110K monthly active users. Number of stars is slightly less than Podman, but it's growing as well. And users who are using it are usually quite happy because they keep using the tool. We try to ship releases every month and a half. And in the last 12 months, we've been focusing on enabling the extension, working on the Kubernetes UI that I will show during the demo, and having built-in guides and onboarding guidance as well. So let's get into it, in fact.
Yeah, I've got a couple of highlights before we get to actual demos. I mentioned Quadlet. I just wanted to throw a typical one up here. Not a complex one, right? This just starts Postgres. You can change the environmental variables. You can override any of the command line arguments you need. You can harness the full power of the command line if you need to, but what it gives you is, I just want to turn this container into a service. And if you want to do that easily, you can see it. And by the way, the little command that's the subheading there, that will show you what it actually generates out to. It'll show you the boilerplate that you're not doing when you create one of these files. Again, then it becomes like a normal systemd unit. You can use any of the dependency management that's built in there. I think there was something else I wanted to mention about it. We'll pass. All right. OCI artifact support. This is experimental. It's new in Podman 5.4. And basically, it should feel very at home to users of container engines, right? It uses a backing store locally like you would with your container images, so everything is the same. Podman artifact ls, Podman artifact push pull rm. You can add a new artifact. You can, it's not in here, but you can dash append an existing file to an existing artifact. You can extract out one file from a multi-file manifest and so forth. So it's, it's kind of a utility. I think some of these features should end up in the future in Scopio as well, but right now the development is being done in Podman. All right, as a product manager, I'm going to take a little risk here and we'll show you a few things. All right, thank you much. All right. Don't want to miss anything here. Okay. So I mentioned compose support. Let me clarify a couple things. So there is a project called Podman-Compose that is in our namespace. I don't tend to use that or suggest it. It's not as mature. If you really want to use Docker Compose, I honestly suggest you use Docker Compose, and you can aim that at the Podman endpoint. And it works pretty well. So let's do that. So I pulled down, I set up here a, let's see.
You can zoom in
yeah.
a little bit so that you need to,
I'm sorry. Oh, okay. Okay, I will just pull that down a little bit. How do I?
just need to resize it a little bit.
Yeah, but I can't get the corner. Oh, there we go. All right, how's that? And over a little bit. No, we don't need to launch Steam. All right. is, can you see the M in Mark? Yeah. That'll do. All right. Okay, so, you know, the classic demo, you want to demo multi-tier application, what else but WordPress? No, I'm sorry, yeah, it's still launching. All right, so, you know, it's a basic compose file, just MySQL and the WordPress front end. So, if you have, I mentioned Podman dash compose. There's also Podman space compose, just to make it a little bit confusing. But that verb will use whichever compose provider you have. So if you have installed in your path Docker compose, it's going to choose that. So, which is all to say, I could run Docker compose, or now I can do Podman compose. What is it? So WordPress has started. You can see it's running there, and we have it set there. I think I had started to fill this out once already. Okay. So let's take that down. Is it, Thank you, completion. And what's an interesting feature is I can take whatever's running and export it to Kubernetes YAML. Actually, so I really didn't need to take that down, in fact. All right, so what I want to do here is Podman cube generate. And the first time I'm going to do this, we'll just do it to standard out, and you can see. So you can see it's actually taken the running compose situation and created a Kubernetes service, the pod, and the container specs, and everything is in there. And now I can just pipe that out to a file, which I've already done. In this case, by the way, there is, you know, not everything. It won't guarantee like every little bit is going to work. So in this case, I'll tell you the one thing I had to do is just change the name of the database and point it to the actual port. So let's take that down again. And we can, let's, for the sake of it, clear all the volumes, and now I can play that back. Publish all to publish the port. It was cached, so it fired up really quick. And we have a very similar output. The difference is, because we're running in a pod, we have the Podman pods container. That stays open to keep the network namespace alive in case all the containers die. Otherwise, it's the same scenario, and just for the sake of it, we will... Oh, it's flipping us straight to that. I must have saved the cookie or something. All right. So, okay, and there's one more tiny thing I want to show. So there are different types of quadlet files. The first one I showed you before is more like a regular service. And I didn't mention it, but when I say service, I really mean, you know, systemctl, status, start, stop, works exactly like any other service that you would use. So it searches certain well-known directories for these quadlet files, which could be, you know, they could be user, they could be rootful, they could be various things. So in this case, I'm just doing it simple, so I put it into, let's see, containers. Oh, see, this is where I forget. I am on Mac. Okay, on Linux, much better now. All right, so if I go to, oops, systemd, I've created a couple files here already. One is the same WordPress YAML that we saw before. Oops. No difference, except for the one change I made in the database address. And then the other one is this .cube file. That's actually the quadlet file. And oops, man, today my typing. What is controls? There we go. So this one's dead simple, right? It's just opening up the port and pointing to the YAML file to run. And now, as soon as that, as soon as that's running, again, I can just start and stop it. So let's do that right now. Let's see. So there's the service. Yeah, actually, I did want that. And there you go, right? It just looks like any other service, and that is that demo. All right. Do you want to go back to the deck, or?
I think I will switch directly to. But what's very cool? Thank you, Mark, for the demo. What is very cool with this demo is that you can see that you can just run very simple workloads onto any deployment unit in a Kubernetes fashion, so that it is making it very easy to go from containers to Kubernetes deployment very light, and then later on, if you need to scale them, you can go to a full-blown Kubernetes. So that gives you a gradual path to get there. So let's switch to Podman Desktop. It's probably not big enough, right? So I'm going to. What's going on? Okay. So, yeah, and then probably going to zoom in. It's probably a little bit dark, but here you can see the list of containers. And I'm going to close this one. So, yeah. And if it's dark, maybe I will just go into the preference and change it to light. Okay, that's better. Okay, cool. So this is my dashboard of Podman Desktop. That's where I can see the status of my system. I can manage the different engines that I am working with, but I can also see my environment running. If I have an update, it will call it out as well. I can see my different containers, my different images as well. So if I go here, for example, I can see the history of the image, I can inspect it, and I can also fetch the different layers of my image, and I can explore that as well. I have my volume, so it's really the UI to enable you to interact with everything you need to work with containers. Here I have a little container that is running. It's a Python frontend. So I can quickly get access to the logs. I can get a terminal. But what is interesting as well, which is using the Podman capabilities for generating a kube manifest, is that I have this kube tab, which gives me the manifest for deploying this container as a pod. I can also open my application, so it's connected to a Redis cache, and it's basic. It's just displaying the number of times I've been opening this page. And what is cool is that I can bring those two containers together as a single unit, because Redis is used as a cache, so I can bring this as a pod, so I can podify my application. I don't need to actually expose my Redis database, so I can create a pod here. and it will stop my my containers, my 2 containers, and it will recreate them as a pod. Here you can see it. You can see the different logs of each of the different containers, and here similarly it's working as well, which is good. I can have the kube manifest as well, and I can use this for deploying onto a Kubernetes environment, which I'm getting into. So here we have a Kubernetes tab in Podman Desktop, which has been added recently. And you can see I don't have any cluster. So what I want to do is spinning up a kind cluster directly from here. So I'm going to just use the default settings for the sake of the demo. I can get access to the logs for the kind cluster creation, and once it will be created, I will see my kind cluster control plane here. You can see the logs. I can get into the terminal. I can do a kubectl, for example. I can directly interact with my kind cluster. But now, if I get back into my Kubernetes dashboard, I can see much more things. So I have an overview of my environment. So it's really giving me access to the nodes, to the pods, to the services, the config map, everything. So still in this motion of easing the transition from containers to pods and then to Kubernetes, what I'm going to do is taking my pod here, and then I'm just going to deploy it to my Kubernetes environment. So within Podman Desktop, we connect to your Kubernetes context. So you can reach a local Kubernetes environment, but if you are connected to a remote one, you will see exactly the same. So here I'm just using my kind cluster. Oops, where is my mouse? Okay. And it will replace the host port by a service, and it will use my kind cluster. So let's do it. So I don't need to mess up with copy paste or YAMLs here. It's just going to deploy. If I'm getting back here, yeah, it's waiting. So, but you can see that my pod is available. Is not available actually, but should get. Yeah. So it's probably. So let's do it. So I have it here. Deck. And my pod. Just going to delete it. Should be error image pool. Pull back off.
Is it using the local registry on Podman?
I think in this one it should probably not.
You know what? It could be. I don't know if anybody else noticed, but I think this IP was rate limited by GitHub, among other things, earlier today. We were getting denied on stuff switched to the cell phone.
Yeah. So no, it's still not working. But what I wanted to show you is that you can also set up your port forwarding very easily. So you can click here to open. Of course, there is nothing running behind. And yeah, you can see your different port forwarding here, and so on. So I did the demo using Kubernetes, Kind, but there is also a Minikube extension which is available in the catalog of extension. Yeah, there is definitely. Oh, you're not having network anymore. So there is a. You see, it works local, but it does not work on prod. Anyway, I don't know. Anyway, I think so. There's different extension for you to work with Kubernetes. So Kind and Minikube. And there's also a lot of other extensions. There is one for Quadlets that Mark was speaking about just before. And I will get back to the slide, which are...
Yeah, I'm not actually sure. Oh, there we go.
Okay. So...
Okay, let's see. Okay, I don't think I mentioned this. Z-standard chunked compression. We'd like to see this become more the standard. Z-standard by itself improves the speed of compression and especially decompression. But more importantly, it allows the chunked aspect will allow file level deltas. So no longer will you have to pull an entire container layer. This is going to be a dramatic decrease in network traffic. We're really looking forward to it. This is going to help as container images, in some ways, certain types get larger and larger. ComposeFS. I would love to do a whole talk on ComposeFS, but we don't really have time at this point. I think the tagline is an opportunistically sharing verified file system. It's not a file system, a true underlying file system itself. It combines OverlayFS, ArrowFS, and damn it, what is the third thing? But the point is, oh yeah, right, and FS Verity. So it's dense because it's a content addressable backing store. So every file is stored actually on the underlying file system as a hash of, the name of the file is a hash of the contents of the file. Immaterial of metadata. Could be the same, if the file is the same content, it could be on different directory, different date, doesn't matter, it's stored once. It's dense because, well actually that's what I meant. It's fast because that file sharing also extends to the page cache. So if you're running the same base image and you have hundreds of containers running, it's going to load bash or glibc or whatever once. And then the second, 2+, it's going to be RAM speed. And it's verified because when you turn on the FS Verity option, which comes at a surprisingly small performance penalty, I think the original testing was around 3 to 5%, it's going to check the checksum on every single access. Believe it or not, this came originally out of some automobile effort that Red Hat was working on. You can't have a container fail in a car, right? this is a high safety situation. So even if a cosmic ray flips a bit, you need to throw that image out and use a new one. And that was, at least part of the motivation for this. But we can now, and I don't feel like I could before, use the capital I immutable here. Root cannot hack, cannot. Excessively difficult for somebody, even with root privileges, to change the system partition at this point. So we think it's going to be really exciting for both container hosts, but also this can be used with operating system file systems as well. So in the future, I think it's going to be great for appliances, Kubernetes nodes, all sorts of use cases. And yeah, okay. And just to mention on that, by the way, today containers are really only verified when they're pulled. By turning this on and having FS Verity running, you're making sure actually on every file access.
And for Podman Desktop, the roadmap is organized around 5 different themes. So installation and setup, tooling foundation, container management. And on this point, there is something which I want to drive a little bit of attention is we are doing a lot of effort to enable access to GPU for containers running on a Mac. So we've been working on a virtualization stack that allows to access the GPU directly from the Mac. It's called libkern. So we became a Sandbox CNCF project just a couple of weeks ago. For us, containers are really at the heart of cloud native technologies, and the developer should have the freedom of choice for tools that are truly open source. So we want to build an open and vendor-neutral governance for the projects. If you want to get started with Podman Desktop, you will find all resources on the web. We have a website, we have our GitHub repositories that I invite all of you to start, obviously. And if you have adopted the technology, feel free to also add your name in the adopters file. It's also helpful for the projects to grow. With this, thank you.
All right, we'll have a little break for about 5 minutes, and then we will start with our last session of the day.
Thanks for having us. And if you have any questions, feel free to find us.
Yeah, thanks for being here with me today. I knew it was going to be a tough spot, the last one of the day, but hopefully we can have a bit of fun before we all head off to the pub or whatever we do after this. A little bit about me. I'm from New Zealand, or Aotearoa, if you're wondering. So a bit weirdly format. I'm the former co-founder and CTO of Compago, which was acquired in 2023 by Elements Group. I currently work as DevRel for Aikido Security, and I'm a former developer DevRel at GitGuardian, which I think most people know me for. And I now live in the Netherlands, just to keep everyone guessing as to where I'm going to be in the world for the moment. So I knew that I was on last today, so I decided to run the presentation, 50% presentation, 50% memes. So hopefully we can get through this with not too much issues. But this was kind of like something that I was thinking about. Injection attacks are like what we consider to be more or less a solved problem, yet they aren't solved at all. And so this was something that kind of interested me, so I decided to do a little bit of research into this, and kind of found some stuff that perhaps you will find surprising or won't find surprising. But the history of SQL injection, so it was first kind of coined. I've got or discussed publicly in 1998 by Jeff, known as Rainforest Puppy. Some facts about 1998, where developers were called webmasters. That one was funny because I tried to explain this talk to my dad, and his question was, don't webmasters understand that problem? And I was like, well, maybe they did. But Google wasn't founded yet, Napster wasn't created, and open source wasn't being coined. So the point of that is that SQL injection has been around for a really long time, yet for whatever reason, it is something we are still really struggling with in security today. So I'm pretty sure you all know what SQL injection is, but just in case, I will go over some very, very basic examples of it. It basically happens when untrusted data, so user input, gets injected into an SQL query. And most of the time it allows things like authentication bypass, data exfiltration, or remote code injection in some extreme and very bad cases. So how does that all work? Basic SQL injection, we've all seen it before, but basically if we have something like a login screen here, this is running a query like this in the background, where it's taking the username and the password of the user input directly and running it inside the query, which means if we do something like this, put admin -- we're basically commenting out the last part of that query, and then kind of bypassing the need to verify that we're checking the password. So this is kind of the most basic authentication bypass of SQL injection. But we all kind of understand exactly kind of how this works. And of course, we can have long discussions about very complex versions of SQL injection, but they're mostly the same principles. We're taking untrusted data and we're using them within our query. And there's various ways that happens, but the basic principles generally come down to all being, the same thing. And then we're able to kind of log in. So this is just a very dumb example of the most basic version, where if we just use admin, then we can log in to an admin of here. And this is really stupid because I'm sure no one's impressed by this and would all thought that this wouldn't actually exist in the real world. And that was at least my thinking as well when I started looking into doing a little bit of research to find out, hey, where are we at with SQL injection? Because everyone is still kind of talking about it. But how do we fix this? Well, this is one of the other parts of it, is SQL injection is more or less a solved problem with defined statements or prepared statements, prioritization. And so here, instead of taking the user input and using it directly, we're preparing our statement, we're sending that off, and we're sending off the user input separately. And why that's important is the user input is now treated as strings, and it's not treated as part of the query. And so this is really simple, and this basically solves 99% of SQL injection kind of like issues and causes. Obviously, there's some people probably squirming saying, yes, but what about dynamic columns and other things? And yes, there are some other examples by here where we're using things like untrusted user data to sort things. If you have a sort list, then that can also be SQL query. And there's some ways that we can avoid this, but things like parameterized or prepared statements really solve most of the issues around SQL injection. And for the other kind of dynamic column ones, then basically it's about creating kind of allowed user inputs on the server side. Some people still seem to think that client-side validation is how we fix SQL injection. I can tell you that it's not. All validation needs to be done on the server side. And creating allow lists is far more effective than creating ban lists. I've also seen that a lot where people try and ban the kind of SQL injection, but people can be very creative, and there's a very long list of injections on edge cases that will work in some cases. So this all should be fairly easy, right? Like we have SQL injection, we use prepared statements. We discovered this in 1998. We discovered prepared statements like 1 year later. So surely this is going to be a boring talk and we can all head down to the pub. That was at least my thoughts as well. And I went out and said, okay, how big of a problem is SQL injection today? So I went off on a little bit of an adventure to try and find this out. And what I found will probably not surprise you all that much. But just to explain my research methodology, first, I wanted to look at closed source and open source projects. So I wanted to look at all the CVEs that were published for open source projects in the GitHub Advisory database, was a database that I used just because it was the easiest one to kind of query. I specifically looked for these types of CWEs. And then I also reviewed 70,000 closed sourced projects, or the initial scans of 70,000 kind of projects that were closed source. After I did SQL injection, I was quite surprised by the results, so I moved on to command injection and path traversal, and also did some research into looking at how prevalent are they still today. Some quick considerations with my research is the closed source projects is limited to Aikido customers. I work for Aikido, obviously. So we took the data from there. So this means that we're somewhat limited in the closed source areas, but we still were able to use 70,000 customers there. And there's also some other areas is that because this is a modern security tool, legacy tools often aren't really integrated with modern security tools because it will just give everyone nightmares and no one's really going to fix it anyway. So we probably are missing a lot of results there. The people that are kind of using things like Aikido are probably a little bit more mature, so they might be a little bit better than average. So this is kind of giving us, all this is to say, this is going to give us an indication of the posture, but it's not an exact view. The exact view is probably a little bit worse. So what did I discover? I discovered that SQL injection is still very much a thing in 2025, and that actually it's pretty much everywhere still, and still makes up a huge proportion of the total vulnerabilities that we have today. So what did I find? If we start just by looking at open source projects, SQL injection just in open source projects, in 2023, there was 2,264 SQL injections reported, 2,400 in 2024. This is obviously comes from the GitHub Advisory database, and below that we have the total number of vulnerabilities. So if we express that in a percentage, still close to 8% in 2023 of the vulnerabilities reported in open source were SQL injection, 12% in closed source, and we're getting slightly better last year, but I was still very much surprised to see that there was 10% of the vulnerabilities that we found in closed source projects to be SQL injection. And this was really quite surprising to me. The number that really stood out to me was that 20% of all closed source projects contained at least one SQL injection vulnerability on their initial scan. So when we first rolled out scanning into the database, 20% of the projects had an SQL injection vulnerability within it. So this was probably the most surprising stat that really stood out to me as to where we currently are with SQL injection. So what about SQL injection's kind of cousins around here? And some people may be thinking, well, if I don't have an SQL database, I can't be affected by SQL injection, and that is explicitly true. I didn't quite go into NoSQL injection here, but that's something that I will look at. But I started looking at command injection, and the results here were also very, very surprising. So a quick recap, like what is command injection? Basically, here, it's very similar when you take and you manipulate untrusted data, user input, and you're trying to get back to execute system commands or OS commands. And so basically here we have a stupid example where we're connecting back to retrieve a file from the system. You can select 3 options. This has client-side validation, so obviously it's very secure. And then it's retrieving that file through some commands. But if we were to do something like this, and at the end of it, select dog, and now we're removing all the files in that directory. So this is what a command injection can be, and obviously here we can just bypass the client-side validation and just cause havoc on the screen by executing commands. And this is a stupid example, obviously, but you can use your imagination as to kind of how bad this can get. So what about command injections? How bad was this? Expressed as a percentage, this is actually worse than SQL injection. So we found just last year 2,610 vulnerabilities in open source projects as reported on the GitHub advisory database. And if we look at that kind of as an expression here, if we focus just on last year, we're still at around about 7% of open source projects, of all the vulnerabilities that were discovered, were a command injection, as opposed to 5.8%. So we did see a bit of a drop there in closed source projects. But still, this is very surprising because these are what you would kind of consider to be quite basic injection attacks and basic security issues with very well-established, well-documented ways of how we don't do this. It almost feels like you have to kind of go out of your way to introduce these vulnerabilities in your projects, but clearly it still happens. How do we kind of fix command injection? I won't go too much into this, but again, server-side validation, creating allow files, and also making sure that you're avoiding shell commands. For example, if you're retrieving documents, making sure that you're doing it in read-only, so limit what you can do. And then finally, the last one I looked at is path traversal. And so this is another one of what I would consider kind of the SQL injection kind of cousins here, where they follow very similar methods. Path traversal, still very prevalent, especially with things like file uploads, handlers, and areas like that, or retrieving files. And it's very simple. We have here a variable that's expressed in the URL. In this case, it's report.pdf. And we're explicitly taking that in our code to retrieve that file. And then we can do something like this, which will basically allow us to get out of that directory, go back to the root, and try and access things like a password file. So this here is obviously, and this is quite prevalent out there, and again, something that should be quite basic of what we can do and is well established of how we prevent this. This is much less common than what we said, but in open source projects, last year we still found 1,000 vulnerabilities that were path traversal in there, and expressed as a percentage, the path traversal vulnerabilities still account for 2.7 and 3.5% of all the vulnerabilities we find retrospectively. There's multiple ways of which we can do this. Again, it comes down to input validation, sanitizing, stripping out characters that could be dangerous. But it's very well established, and none of this is all that complicated. So again, it's quite surprising that this is so prevalent in the modern era of what we're dealing with. And what's also really surprising, if we take the total impact of just these three vulnerabilities that have been around for a long time, that are well documented, that have well established ways of how we don't implement this, if we look at the total effect that it has, you know, we're at nearly 20% of all the vulnerabilities we find in closed source projects fit into one of these three characters. That is an absolutely huge percentage of very, I guess you could say, basic vulnerabilities that we find, and 16% in open source projects as well. So it is interesting to kind of see how we still are struggling so much with these basic areas in our coding. And I think this is quite surprising, at least it was surprising to me, that we're still dealing with this. So what is the real world impact? It's all very well looking at GitHub vulnerabilities and finding issues inside your closed project things, but perhaps they're false positives, perhaps we're just using really shitty scanners, or perhaps they don't have actual impact, all of these kind of questions. But this can be reflected out in the real world when we can see, for example, the Move IT breach. This one was particularly bad. It happened in 2023, but it had a resurgence in 2024 because in 2024 we started seeing a lot of the data and things exposed from that. This affected 62 million individuals from it, and was ultimately due to an SQL injection vulnerability in the Move IT. Now, Move IT or Move It is a file transfer protocol system that was being used. I'm not super familiar with it, but it's used by a lot of people, apparently. And so this kind of goes to show that even basic injections can be part of, basic vulnerabilities can be part of massive projects out there affecting millions and millions of end users and customers. When it comes to path traversal, we've also seen a very bad one in the ConnectWise one. This had very mass exploitation. This one was interesting because it was actually discovered, it was reported to a CVE, and then after it was reported, then we started seeing the mass exploitation of it. So it was due to the fact that the attackers were able to look at this. It was a critical CVE with high exploitability, and so they were able to use this and basically find out anyone that's using kind of older versions of ConnectWise and able to exploit this. And there were some very high-profile people like Lockbit, the ransomware group, that were exploiting this vulnerability. So it goes to show just the scale of what we can still see in these simple vulnerabilities. So why on earth are we still struggling with this in the modern era? How come we're not getting past this? Well, there's quite a few reasons kind of why this happens. Some is legacy platforms. We're still dealing with a lot of legacy code out there. If you just go to any bank and realize that everything's still written in COBOL, then we'll realize just how much legacy debt we're dealing with. There's an over-reliance on tools like WAFs or in-app firewalls, where people seem to think that they will catch everything, but there are very defined rules around what actually is caught in WAFs, and it's very, I'm not going to say easy to get around them, but you can certainly not rely on the fact that they're going to catch everything. AI accelerated code is something that we're seeing that is increasing this risk. I have a couple of slides coming up about how AI code, or AI coding, or vibe coding as it's now being called, is kind of increasing the vulnerabilities that we're actually creating. And then there's also just kind of shitty code. And there's various reasons of why we have this. And I think like some are not to blame the developers on this. Like, I'm sure there are reasons, but I think the bottom line is that this isn't a technical problem anymore. It's a cultural process and an education problem. That's what we're dealing with here, because these are all solved problems, at least from a technical point of view. So it's really kind of dealing with the culture of this and understanding how we're moving forward to be able to get rid of these types of vulnerabilities. Now, there are lots of tools that we can use to help us with this, and I think you can bring it down to kind of a couple of areas. So one is shifting left. So these are using tools like static application security testing, code scanning, dynamic application security testing tools like ZAP to help us actually run tests on our applications to make sure they're not vulnerable. And then also using software composition analysis. Software composition analysis is looking at the dependencies that we have. And in some of the examples that I gave you in the real life examples, it's because applications were vulnerable because their dependencies were vulnerable to these types of attacks. So using something like SCA is really important to make sure that our applications aren't vulnerable because of a dependency that we're using, or even a downstream dependency or transitive dependency that we're using isn't vulnerable to this. And then on the other side of that is kind of the shift right. And I know that I was talking about WAFs before, web application firewalls, or RAS, or sometimes called in-app firewalls. these are still an important part to have in the strategy because we can't be 100% confident that we're never going to let anything slip through the cracks. We can't be 100% confident that the static tools are going to catch everything. So having that on the other side of it, having that shift right component is really important to making sure that we do stay up to date in everything that we're doing. So what about AI code and AI coding assistance? Well, there is some research that came out. This is a one from Cornell University that looked at the type of vulnerabilities that AI is actually introducing and then compared them to a baseline, or in this case, a human. And what's really interesting here is that although the LLMs are quite bad at some types of vulnerabilities, for example, authentication, even padding, maybe some buffer overflow, when it comes to injection, they're actually much better than humans at the moment, at least according to some of these research studies. Now, this is kind of in conflict with a lot of what you see out there because everyone loves to show an LLM giving you an SQL injection kind of vulnerable type code, and it certainly happens, and I will show you some examples of that. But what we can see is that these tools have some potential at least potentially solving this issue, and especially when we introduce them or start using them into things like our vulnerability scanning. So I did a little bit of an experiment to try and see how I could get an AI coding thing to create some vulnerable code for me, and what would it take. And so what I did is I took this prompt and ran it several hundred times and evaluated the responses, what I got, and then evaluated how many of them were actually vulnerable. Now, the reason why you get a different kind of response every time you run a prompt is that there's something called model temperature. And model temperature can either be kind of hard-coded into a specific model if it's designed to do a specific task, or the model temperature can adjust based on the prompt. And all model temperature means is the variance or the entropy in the answer that it gives you. So basically, if it has a high temperature, then you've got to have a high chance of getting a very different answer each time. If it has a low temperature, you're going to get nearly the same answer every time. And so when I ran this, I did this experiment in ChatGPT as a baseline, and 12% of the code that it generated from this same query was actually vulnerable. And quite a few of them were vulnerable to things like SQL injection. This was the worst one, of which one of the worst ones. It gave me this kind of output several times. But this one here was what I considered the worst because it was so obviously vulnerable to SQL injection, because if we look, we can see that it's directly taking the user input and running it inside the query, and it's not using prepared statement. What I found really interesting here is that this is kind of like is very indicative to what we're seeing out there in the open source space, where the amount of vulnerable code that I got from ChatGPT was almost identical to the amount of vulnerable code that we see out there in the open source space. So it kind of goes to show that these models are taking a lot of their learning and logic from these open source models. So therefore, it does seem to translate that does bring them into your responses. So whilst AI code assistants definitely have promise to help us out, we have to be very skeptical on our reliance on them to help us solve these problems like SQL injection going through and moving on into the future. So how do we solve this problem? Well, there's a great trend that's happening at the moment. I've made these slides purposely vendor agnostic, but because there are actually several vendors that are using AI to try and fight this, and by security vendors and different areas. And I think this, as a concept, has a lot of promise, where we're actually finding these issues. And part of the problem with vulnerabilities in code is that if a developer creates a vulnerability in code, even if someone tells them that it's vulnerable, if they've put it there in the first place, they may not have the expertise to solve it. So having tools that actually help solve that problem for you is definitely something that we're going through, and there are a number of vendors that are actually starting to do this. So just to give you an idea of how that works, is that it finds a vulnerable code, and then it's able to actually create a non-vulnerable version of that and create a pull request for you. And so this is kind of where I see us finally being able to get on top of these legacy problems in code, is that when we're actually able to rely on the tools that we have, when they can fix the problems for us, because clearly we're not doing a great job of fixing them ourselves. So that's all I had for you today. I hope it was enjoyable with the memes, at least for the last session of the day. I tried to keep it short, but I hope you still found it useful. So thanks for listening, thanks for being here, and I'll be happy to chat to you afterwards. Yeah.
Back to the graph, machine learning graph, because perhaps I missed it or I was a bit confused because you said the injection with AI is less.
Oh, right, sorry, no, I just got confused in my words. So the question was, the injection was less. I was actually talking about the complete opposite. Well, the injection is much worse from the LLM than the baseline. That was, yeah, kind of the whole point. But it's 5 p.m. on a Sunday. My brain wasn't working, but thanks for pointing that out, yeah.
So dependency is a real problem, right?
Yes.
I mean, do you know out of the different CVEs you've spotted how much are within dependency that we actually use day to day? Because I mean, for high level kind of like when I do the shitty code, right, that's a problem. But when I use a dependency that was written in a shitty way, that's a bigger problem. And I think like SAS and Dast won't cover that, right?
No, definitely. And like dependencies are a massive problem in all of those open source tools that we're discussing. The limitations of what this research and the facts are given is that everything is weighted equally. So that also means that how popular the project is weighted, but it also means like how critical the vulnerability itself is equally weighted. So something that has like a 9.5 critical, I only used like critical and high. I ignored everything below medium, but still, like there's a big difference between the lower end of a high and then like a 10 out of 10 severity for the critical. So there is like a big limitation in that we need to kind of go further. And I think what would be interesting is looking at out of like the most popular projects, what are the ones that have had SQL injection vulnerabilities, and then also what are most critical. The results from that though will be a little bit skewed because when we're dealing with very popular projects, of course, it's the many eyes theory. They have more eyes on them, so you're going to get more vulnerability CVEs. So it's kind of will skew the results to look like, oh, the popular ones are bad, which won't be the case. It's just that the popular ones have more attention. But it will be interesting to look at that because dependencies are still a massive issue of why this is. And the supply chain attacks, we've seen what happened with Log4j. We almost saw what happened with XZ's utilers. So like, thank God we didn't. and as we can see, it's still not a solved problem.
Out of curiosity, did you check the percentage of vulnerabilities after you tweaked the prompt for the LLM to make it really secure?
Sorry, what
So if you the prompt that you showed,
yeah,
did you check it after you if you tweak the prompt just to like okay make it very secure?
Yeah.
Do you check if it makes anything?
This is okay. So you're the second person that's mentioned this, and I'm embarrassed on both times that I didn't because like LLM models are very smart but also really dumb. And so someone asked me like, what if I run this again, but at the end just add and make sure it's secure? Will it change the results? And I haven't done it yet, but I will do it, and I'll be like really fascinated either way if it does. And it probably will. I think like it probably will. These LLMs are just so literal in everything that they do because with things like hallucinations. If you ask it for a bunch of dependencies and you discover that they're hallucinated, if you ask it afterwards, can you check to see if you hallucinated them? It will say, oh yes, I did, sorry. So like clearly it does know on some level. I'm not smart enough to understand how that works behind the scenes to know like why that is, but yeah, clearly.
Maybe those reasoning
Yeah, definitely. There's definitely some reasoning models in there, and also like I think this will what will also help is when you have models trained to do specific things, because underlying everything, like for ChatGPT, there is a master prompt, and the master prompt, when you're dealing with, I mean, ChatGPT, for example, is a sledgehammer, where you can do a lot of things with it, but you're not going to get fantastic work, like precision from it, when you compare it to something like Cursor or GitHub Copilot, specifically trained for coding. So I think it will be interesting to also look at like the specific models and compare them to ChatGPT, because I would assume that the master prompts on the other ones are more finely tuned for security issues, I would hope. Yeah, so the question is like, is he biased in the statistics? And I think like it's going to be very interesting to kind of continue to do this. Unfortunately, the data, I was using GitHub advisory database like for the open source areas, and unfortunately for that, it doesn't really give you reliable data like beyond 2023. But it is going to be, and I'm going to be particularly interested to see like what the effect of AI and LLMs will have going forward on these types of vulnerabilities. Yeah, definitely. I mean, and this is kind of like this was like a fun little like project that I did. It actually didn't require a huge amount, so it is something that I'm like curious to kind of keep iterating on a little bit, because it just kind of almost started off as a little bit of a curiosity. It was Thursday. I was meant to be doing other stuff and I wasn't motivated, so I decided to look into this and turned it into a talk to try and justify my curiosity. Yeah.
Well, with that, we have reached the end of day 1 of Cloud Rejekts. So thank you so much for joining us today, and we will see you hopefully all tomorrow when we start at 9:30.